I'm going to show you the evidence that has Harvard astrophysicists questioning whether we're looking at alien technology, why the object's clockwork pulsing patterns are impossible to explain naturally, and exactly what will happen if this thing hits Mars in September. On July the 1st, astronomers made a discovery that would soon ignite heated debates across the global scientific community. A strange object, later designated 3I Atlas, was spotted entering our solar system. At first glance, it seemed like a typical interstellar comet, the kind of icy body we might expect to pass through from the far reaches of space. Astronomers assumed it would behave like countless other comets, approaching the sun, venting gas and dust, and then fading back into the blackness of interstellar space. But as more data began to pour in, it became clear that this was no ordinary comet. The orbital path, the speed, and the very behavior of 3I Atlas stood out as anomalies. Most comets are unpredictable, but still bound by the chaotic physics of ice and rock. This one seemed to be operating with precision. That's when Harvard astrophysicist Avi Loeb, already known for his bold suggestion that another interstellar visitor, Oumuamua, might have been artificial, stepped forward with a theory that shook the scientific establishment. Loeb suggested that 3I Atlas might not be a random chunk of rock and ice at all. Instead, he proposed it could be some form of alien technology, a piece of machinery traveling between star systems with a purpose we do not yet understand. At first, many dismissed his claims as speculation. After all, it is easier to assume natural origins than to leap to extraterrestrial explanations. But as telescopes tracked the object night after night, the data started leaning closer toward Loeb's controversial idea. Its movement did not entirely match the behavior of a passive natural comet. Instead, it appeared to respond to gravitational tugs in ways that looked calculated, as though adjustments were being made. This raised deeper questions. If 3I Atlas is not a natural body, then what exactly is it? Could it be a derelict probe from a civilization millions of years older than ours, drifting through space until it found another planetary system? Or is it an active messenger, deliberately launched and guided to pass close to planets like Mars? The suggestion that we may be witnessing alien technology is not one that scientists make lightly. It challenges centuries of assumptions about humanity's place in the universe. But 3I Atlas refuses to fit neatly into the familiar categories of comet or asteroid. It is something different. And the fact that it has come so close to our solar neighborhood, heading toward the red planet, only deepens the mystery. As more evidence accumulates, Avi Loeb's voice has grown louder, urging the scientific community not to dismiss the possibility too quickly. He warns that labeling the object as just another comet could blind us to the reality that we may be looking at the first true sign of advanced life beyond Earth. And if he is correct, then 3I Atlas is not just passing through, it is a message, a machine, or perhaps even a test. When astronomers first locked onto 3I Atlas in early July, the general consensus was reassuring. This interstellar traveler, though fast and unusual, seemed destined to sweep past Mars at a safe distance. It would be spectacular to observe, but ultimately harmless. A cosmic firework flashing by, and then vanishing back into the darkness of deep space. But that sense of calm didn't last long. As more observatories began to feed in their data, both Harvard's team and NASA's Jet Propulsion Laboratory took a closer look at the object's path. What they found quickly erased the comfort of that early assessment. The trajectory wasn't stable. In fact, it was tightening. Instead of drifting along a predictable course, 3I Atlas was bending inward toward Mars in a way no one had expected. Before we dive in, hit that subscribe button and turn on notifications. You don't want to miss any updates on the universe's deepest secrets. And if you love exploring hidden mysteries and unexplained discoveries, give this video a like so we know to keep uncovering them. The updated calculations are nothing short of alarming. According to current models, 3I Atlas is now projected to make its closest approach to the red planet on September 26, 2025. The distance? Just 1.95 million kilometers. In the scale of interplanetary space, That's razor thin, close enough that Mars's gravity could actually begin to tug at the object, influencing its motion in subtle but critical ways. To put it into perspective, this distance is about 5 times the gap between Earth and the Moon. In everyday terms, that might sound wide. But in orbital mechanics, it's a cosmic near-miss. The difference between a safe flyby and a direct impact comes down to tiny deviations, sometimes no more than a fraction of a degree or a few seconds of acceleration. And with every hour that passes, gravitational nudges from the Sun, Jupiter, and Mars itself are reshaping 3I Atlas's course in ways that add up over millions of kilometers. Astronomers describe the situation as a balancing act on a razor's edge. Even now, as predictions improve, the object's path is being updated almost daily. The closer it gets, the harder it becomes to ignore the possibility that Mars could end up directly in the crosshairs. What makes this more unsettling is the speed at which these changes are happening. Normal comets can wander in their orbits due to outgassing, plumes of gas and dust that act like tiny thrusters. But 3I Atlas is accelerating and adjusting in ways that look deliberate, not random. Every shift in its path seems to tighten the noose around Mars, as if the red planet is the destination rather than an accidental bystander. If these calculations hold, Mars is not just going to get a close encounter. It could be staring down the most dangerous cosmic visitor in its recorded history, and the date is already circled on every astronomer's calendar. Late September 2025. That is when we will know, once and for all, whether 3I Atlas will simply graze past Mars or collide with devastating force. If the trajectory of 3I Atlas wasn't enough to raise alarms, its sheer speed has left scientists stunned. This object is not just moving fast, it's moving faster than anything humanity has ever recorded coming into the solar system from interstellar space. Current measurements place its velocity at an astonishing 87 kilometers per second relative to the Sun. To put that into perspective, imagine the vast gulf between Earth and the Moon, a distance of nearly 400,000 kilometers. At its present speed, 3I Atlas could cover that distance in less than 80 minutes. That is faster than the speed of most spacecraft by several orders of magnitude, faster even than the escape velocity needed to break free from our solar system. It is, quite literally, a bullet tearing across the cosmic void. But speed alone isn't the only concern. The more dangerous factor is what happens when an object moving this fast interacts with the gravitational forces of the solar system. Every planet, every moon, even the Sun itself exerts a pull. For a normal comet, these tugs shift the orbit slightly, nudging it onto a new but still predictable path. For something as fast and massive as 3I Atlas, however, even the smallest nudge becomes magnified over time. Astronomers have calculated that with each passing hour, the object's trajectory is being adjusted by mere micrometers per second. On paper, that might sound insignificant, almost laughably small, but stretched across tens of millions of kilometers. These minuscule changes add up to vast deviation, enough to alter whether the object harmlessly grazes past Mars or collides with devastating precision. This is why scientists describe the situation as unstable. 3I Atlas is like a high-speed train racing along a track where even the slightest bend could send it careening into disaster. Its momentum makes it incredibly resistant to stopping, but frighteningly sensitive to the tiniest directional changes. That combination of unstoppable speed and razor-edge instability is what has NASA and Harvard astronomers on edge. The real question is this: are these shifts in its path purely natural, the result of random gravitational pulls and chaotic outgassing? Or are they being guided, deliberately steered, to ensure a closer and closer pass toward Mars? If the latter is true, then this isn't just a speeding interstellar rock. It's something with intent, something capable of navigating with precision at velocities that dwarf anything humanity has ever engineered. The faster it moves, the harder it is to ignore what is at stake. A flyby would be historic enough, the fastest interstellar visitor ever observed. But a collision at these speeds would unleash energy on a scale almost beyond comprehension. And every hour that ticks by brings the object one step closer, its course more refined, its future more uncertain. For centuries, astronomers have studied comets and their behavior as they journey closer to the sun. When sunlight strikes a comet's icy surface, frozen gases sublimate, venting into space in random bursts. These eruptions create the glowing tails we see streaking across the sky. But the one constant in cometary science is chaos. The vents are unpredictable, irregular, and never precise. Atlas, however, is breaking every rule. Instead of releasing gas at random intervals, telescopes around the world have detected an astonishing pattern: precise, clock-like pulses every 17 minutes. Not once, not twice, but over days of continuous observation, this rhythm has held steady, as if the object were running on some kind of internal timer. This is not the behavior of a natural body. No comet in the solar system has ever demonstrated anything like it. In fact, scientists liken it to the ticking of a metronome or the steady firing of thrusters on a spacecraft. Each pulse releases gas in a controlled burst, producing just enough force to subtly shift the object's path. And when those shifts are added together over time, they form a clear pattern. The object is being steered toward Mars' orbital plane. Think about the implications. Natural comets vent when sunlight heats fresh patches of ice, and those eruptions are chaotic. Jets firing here, then there, often breaking apart the nucleus as the comet tumbles through space. But 3I Atlas behaves with an eerie precision. The gas doesn't erupt randomly. It fires in deliberate, synchronized jets, as though following instructions. Astronomers watching this phenomenon have admitted that no known natural process can explain such clockwork regularity. One researcher described it as attitude control, the exact same technique spacecraft use to adjust their orientation and trajectory with small bursts of propellant. It's as if 3I Atlas is flying itself, adjusting its course step by step as it races through the solar system. And the target of these adjustments? Mars. Each synchronized outburst appears aligned to gradually reduce the missed distance, pulling the object ever closer to the red planet's path. By September of 2025, the cumulative effect of these tiny pulses could shrink the gap from millions of kilometers to just tens of thousands, closer than some of Mars's own moons. If this is merely coincidence, it is the most extraordinary one in the history of comet science. But if it isn't, then what we are watching is no random outgassing at all. It is navigation, deliberate, precise, and perhaps purposeful. The question then becomes chilling. Who or what programmed this interstellar traveler to behave this way? The tightening trajectory of 3I Atlas has led to one terrifying possibility: a direct collision with Mars. Right now, the object is still on course for a near miss. But astronomers warn that it wouldn't take much to tip the balance. A change of just 10 kilometers per second in velocity, a tiny fraction compared to its current speed, could redirect the object straight into the red planet. This isn't a far-fetched what if. The outgassing pulses already observed are providing small but steady bursts of thrust. And if one of those bursts happens to align just right, it could provide the additional momentum needed to shift its orbit into a collision path. In other words, the comet may already have the means to deliver that final push. If impact occurs, the consequences for Mars would be catastrophic. Scientists estimate the mass of 3I Atlas at nearly 10 billion tons, with a dense metallic core roughly 400 meters across. A body of that size striking at interstellar velocity would unleash an explosion equivalent to 2 million megatons of TNT. That's not twice the yield of the largest nuclear device ever tested. It's thousands of times greater. The crater left behind would be apocalyptic in scale, 60 kilometers wide and 5 kilometers deep, a wound carved into the Martian surface that would remain visible for eons. Shock waves would ripple across the planet, while molten debris would be thrown high into the atmosphere and far into space. Some of it could even escape Mars's gravity entirely, spreading across the solar system. And the damage wouldn't be confined to the planet itself. Mars is a hub of exploration, home to orbiters, rovers, and landers from multiple space agencies. Satellites like the Mars Reconnaissance Orbiter, the European Mars Express, and surface missions like Perseverance and Curiosity form the backbone of our Martian science. An impact of this magnitude could destroy or cripple decades of progress in a single instant. Communications relays could vanish. Climate data, life search missions, and future human exploration plans could all be set back by generations. For scientists, the potential impact represents both nightmare and opportunity. It would be the largest planetary collision witnessed in the modern era, a once-in-a-civilization chance to study interstellar material interacting violently with another world. But it would come at an enormous cost, the loss of billions of dollars in equipment, and possibly the contamination of Mars itself with materials that may not be natural at all. The thought that this could happen, not in millions of years, but in just over 12 months, is what keeps researchers awake at night. September 26, 2025, looms ever closer, and with it, the possibility of a collision that could rewrite the history of Mars, and perhaps the history of intelligent life in the cosmos. Up to this point, the anomalies of 3I Atlas could be explained away, at least in theory, as rare but natural behaviors. An odd trajectory, strange gas emissions, even its incredible speed might be stretched into the realm of possibility. But the most recent evidence is something altogether different. Deep space radar facilities, including NASA's powerful Goldstone Solar System radar in California, have been quietly tracking 3I Atlas since its discovery. Normally, when comets are scanned this way, the echoes return soft and diffuse, consistent with surfaces of ice and dust. But the radar profile of 3I Atlas was nothing like that. Instead of scattering gently, the radar beams bounced back with hard metallic echoes, the kind of reflection you'd expect from steel, titanium, or other dense alloys. Materials like these are not formed naturally in the void of interstellar space. They are forged, engineered. For weeks, these results were kept classified, locked away in restricted data servers. But leaks began circulating among the scientific community, hinting at something extraordinary. Harvard astrophysicist Avi Loeb, already controversial for suggesting Oumuamua might have been artificial, went public with his interpretation. Working with one of his graduate students, he argued that the echoes prove 3I Atlas is not just another comet, but a structure, possibly a technological artifact, cloaked beneath a thin shell of ice to masquerade as a natural object. This theory may sound like science fiction, but consider the evidence: the precise, timed-out gassing pulses behaving like thrusters, the deliberate alignment with Mars's orbital plane, and now, radar signatures indicating alloys unknown in natural comets. Loeb describes the object as resembling an interstellar probe, a machine built by some intelligence, its metallic frame hidden beneath volatile ices that create a convincing comet-like disguise. The ice would not only provide camouflage, but also serve as fuel, vented in exact amounts to alter its trajectory, just as we've observed. If true, 3I Atlas could be the first piece of alien technology humanity has ever encountered up close. Not a distant radio signal, not a mathematical anomaly. A physical machine, a visitor crossing the gulf between stars. But if this is technology, the biggest question isn't how it works. The question is why it's here, and why, of all the planets in the solar system, it seems to be steering itself toward Mars. While scientists debate whether 3I Atlas is natural or engineered, a series of unsettling observations from Mars has pushed the discussion into darker territory. The European Space Agency's Mars Express orbiter has been circling the red planet since 2003, providing some of the most detailed imagery of its surface and atmosphere. But in the last several months, its instruments have recorded something unusual: 3 small, highly reflective objects glinting just above the Martian atmosphere. At first, mission engineers brushed it off. Cosmic rays often streak across detectors, leaving behind bright specks that mimic objects in space. But this wasn't a one-time glitch. The same three reflections appeared again, and again, and again. Each time, they were in the same positions, locked in what astronomers now describe as a triangular formation. Cosmic rays don't form triangle, and they don't maintain formation across multiple imaging passes. The unsettling implication is that these aren't sensor artifacts at all. They could be physical craft, small probes or satellites, deployed silently into orbit around Mars. Their reflectivity suggests metallic surfaces, and their spacing is consistent with a controlled configuration rather than random debris. If this interpretation holds, it leads to an extraordinary hypothesis. 3I Atlas may not be arriving alone. It could already have dispatched scouts ahead of its approach, like reconnaissance drones preparing the ground for something larger to come. The timing is difficult to ignore. These reflective anomalies first appeared in the months after 3I Atlas was detected entering the solar system, as if its presence was the trigger. Skeptics argue there must be a mundane explanation. Fragments of Martian moons, perhaps, or untracked space junk from past missions. Yet neither Phobos nor Deimos can account for their exact altitude or their stable geometry. And human spacecraft? None are known to be operating in that orbit, let alone in precise triangular formation. If these really are probes, their mission is a mystery. Are they monitoring Mars's surface? Mapping its resources? Tracking our satellites and rovers? Or are they simply waiting, relaying data back to the larger object on its inbound course? For the first time, scientists are being forced to consider that 3I Atlas may not just be a visitor. It may be conducting operations, coordinated, strategic, and deliberate. And if that's true, then its destination isn't random at all. Mars may have been chosen long before we ever spotted it. The moment the anomalies of 3I Atlas became undeniable, the world's space agencies quietly shifted gears. Publicly, their updates remain calm, routine, and even dismissive, the kind of language designed to reassure rather than alarm. But behind the scenes, a very different story is unfolding. According to leaks from inside the aerospace community, the major space powers, NASA, ESA, Roscosmos, CNSA, and JWST, have all formed emergency planetary defense task forces. These aren't ordinary working groups. They're cross-agency teams designed to share classified data, track unusual threats, and coordinate potential responses. In short, humanity's first line of defense against the unknown. While the press releases speak blandly of monitoring efforts, internal documents suggest something far more serious. A memo leaked from NASA's Jet Propulsion Laboratory describes efforts to repurpose existing spacecraft around Mars. Probes like the Mars Reconnaissance Orbiter, once dedicated to mapping the Martian surface, are now being retasked to focus almost exclusively on 3I Atlas. Every maneuver, every anomalous burst of gas, every flicker of reflected light is being logged with military-level precision. ESA's Mars Express 2 has been placed on a new observation schedule, tasked with keeping its cameras fixed on the strange reflective objects in Martian orbit, the ones some now believe to be scout probes. Meanwhile, China's CNSA has quietly announced unplanned adjustments to its Tianwen-1 orbiter, a cryptic phrase that analysts suspect also means redirection toward tracking 3I Atlas. The secrecy is telling. None of these agencies are openly admitting to the scale of their concern, but the coordination itself is unprecedented. These nations are rivals, often reluctant to share even basic mission data. And yet, in the case of 3I Atlas, information is flowing rapidly between them, as though they all recognize the stakes are too high for competition. There are even whispers that military satellites in Earth orbit have been reassigned to deep space surveillance, feeding classified intelligence directly to these planetary defense teams. If true, this means the response is no longer purely scientific. It is strategic, defensive, acknowledging that this object might not be just a natural hazard, but a potential technological adversary. For now, the public sees only calm statements and routine reports. But behind closed doors, humanity is mobilizing. Because if 3I Atlas is truly artificial, then its approach to Mars may represent not just a scientific puzzle, but the first interstellar test of whether our civilization is ready to face another. Even if 3I Atlas were to narrowly miss Mars, the consequences of its close encounter could still ripple across the solar system. A collision, or even a near miss at high speed, would send shockwaves through space in ways that go far beyond the red planet itself. Scientists warn that an impact could eject millions of tons of debris into interplanetary space. Some of this material would remain trapped in orbit around Mars, forming temporary rings of dust and rock. Other fragments could escape the planet's gravity entirely, hurtling through the solar system at incredible speed. These aren't ordinary rocks. Given the possibility that 3I Atlas may contain metallic or engineered components, some of the debris could carry traces of material that are artificial or highly unusual. Computer models predict that certain fragments could reach the vicinity of Earth within a decade. While most would burn up in our atmosphere, larger or more robust pieces might survive entry, landing on our planet or in near-Earth orbit. The implications are unsettling. If any fragments carry engineered microbes, chemical compounds, or even self-replicating nanotechnology, they could introduce previously unknown elements into Earth's environment. This scenario moves beyond the realm of planetary science and into biosecurity and astrobiology. Governments and space agencies are acutely aware of the stakes. What arrives from Mars in 10 years could, in theory, carry interstellar materials that are entirely new to life on Earth, or worse, potentially hazardous. Even if a collision doesn't directly threaten Earth, the debris field could create hazards for spacecraft, satellites, and future missions throughout the inner solar system. Every probe, rover, and satellite operating in the path of Mars's orbital debris would need recalibration and rerouting to avoid catastrophic impacts. What's clear is that the risk is not isolated to a single planet. A single interstellar object, moving at extreme speed and potentially under intelligent control, could reshape the solar system's environment for decades. Mars may be the immediate target, but the ripple effects, fragments, debris, and possibly engineered materials could extend all the way to Earth and beyond. For astronomers, this is both a warning and a call to vigilance. The universe is vast, but objects like 3I Atlas prove that a single, small point of light racing through the void can have consequences on a planetary scale. As the data on 3I Atlas continues to mount, a sobering possibility emerges. What if this interstellar object is not just a random visitor? What if it is maneuvering deliberately, adjusting its course with precision, and approaching Mars for a reason? If that is the case, then humanity may be on the brink of witnessing something truly unprecedented, the first confirmed extraterrestrial technology in human history. For decades, we have imagined the ways we might detect intelligent life beyond Earth. Most discussions focus on radio signals, faint whispers sent across the cosmic void, waiting for a civilization like ours to listen. We have scanned the skies, hoping for a message hidden in the static. But 3I Atlas challenges that paradigm entirely. It suggests that first contact might not come through communication at all. It might come as action, as a physical object crossing light years, carrying a message, a probe, or even a test of our observational skills. This shifts the conversation from passive listening to active awareness. If 3I Atlas is indeed an intelligent artifact, then every gas pulse, every slight adjustment in its trajectory, is a signal in itself. It may be observing Mars, studying our solar system, or gauging how we respond to its presence. The object's approach is not random. It may be designed to interact with us indirectly, testing our ability to detect, interpret, and react to extraterrestrial engineering. The implications are staggering. A guided interstellar impactor could represent a civilization millions of years ahead of ours, capable of constructing and controlling objects across interstellar distances. It would suggest that intelligent life has not only survived, but mastered technology far beyond anything we can currently comprehend. And the potential consequences extend beyond mere curiosity. A collision with Mars could alter the planet physically, possibly releasing debris into the solar system, fragments that might even reach Earth over the coming decades. If any of these fragments carry engineered material or other technologies, the impact would have ramifications that reach far beyond the immediate scientific community, touching on planetary defense, biosecurity, and the very question of humanity's place in the universe. For astronomers, physicists, and planetary scientists, this is the opportunity of a lifetime, a chance to study an interstellar object in real time, possibly confirming the existence of intelligence beyond our planet. For everyone else, it is a cosmic warning. The universe may be far stranger and more active than we have ever imagined. As September 2025 approaches, all eyes will turn to Mars and the sky above it. The silent pulses of 3I Atlas may soon answer the age-old question, are we alone? But the answer may come not as a gentle signal, but as a glowing green comet, racing at unimaginable speed, threading the eye of a cosmic needle, and possibly rewriting humanity's understanding of its place in the cosmos. The universe is watching, and so, it seems, is something else. As we watch Mars rise in the night sky this September, remember that above the rusty horizon, something extraordinary is unfolding. 3I Atlas is threading the eye of a cosmic needle, pulsing its strange green exhaust, adjusting its path meter by meter. We do not yet know if it is a natural object, a guided interstellar visitor, or a piece of technology from a civilization far beyond our own. But one thing is clear, the universe has a story to tell, and this time, it may be coming directly to our celestial neighbor. Whether 3I Atlas passes safely, grazes Mars, or collides with devastating force, humanity is witnessing an event unlike any in recorded history. A cosmic experiment, a warning, or perhaps a first contact that challenges everything we think we know. The question remains, are we alone, or is someone, or something, out there, watching, testing, and reaching across the stars? Keep your eyes on the skies. History is unfolding, and soon we may see the answer in motion. If you found this journey through hidden science, cosmic secrets, and potential alien infrastructure as mind-blowing as we did, make sure to subscribe and hit the notification bell. Don't miss future explorations into the universe's deepest mysteries, because some secrets are just waiting to be uncovered. What happens when a 4-kilometer-wide interstellar object defies the fundamental laws of physics and suddenly changes course in the vacuum of space? Right now, scientists worldwide are in absolute panic mode as I-Atlas, an object older than most of our galaxy, just performed an impossible maneuver that has NASA, ESA, and every major observatory scrambling to understand what we're truly dealing with. The acceleration readings? They match the combined thrust of multiple Saturn V rockets. Yet there's no visible propulsion system, no exhaust trail, nothing that should allow this ancient visitor to alter its trajectory. But that's just the beginning of this unprecedented situation. No one in the global astronomy community could have predicted what happened. For years, interstellar objects have been expected to behave according to the unchanging laws of celestial mechanics. Once they enter a solar system, their paths are defined by gravity and momentum, nothing more. But in early July of 2025, 3I Atlas, a massive interstellar visitor measuring nearly 10 kilometers across, proved that assumption wrong in the most shocking way possible. Traveling at an incredible 130,000 miles per hour, this ancient traveler had been expected to follow a perfectly predictable trajectory. Scientists calculated that it would swing around the Sun, pass near Mars, and then head back into deep space, never to return. It should have been routine, at least by cosmic standards. But then, without any warning, the object performed a maneuver that has shaken modern science to its core. In less than 2 days, 3I Atlas abruptly shifted its course, turning by an astonishing 17 degrees. This was no subtle drift, no tiny deviation explained away by gravitational nudges or sublimating gases from its surface. It was a sharp, sudden pivot, more akin to a fighter jet banking in the sky than a natural object obeying Newton's laws. To put this into perspective, altering the trajectory of an object this size requires unimaginable forces. In the vacuum of space, with no atmosphere to push against, a body like 3I Atlas should continue in a straight line indefinitely. The fact that it didn't has left the world's brightest minds scrambling for answers. Across the globe, monitoring teams erupted into chaos. Instruments that once delivered reliable predictions now showed paths diverging wildly. NASA convened emergency briefings in the dead of night. The European Space Agency held a crisis meeting at 3 in the morning. Observatories in Chile, Hawaii, and Spain worked frantically to update their models. Yet every single prediction collapsed as new data poured in. Every physics-based simulation failed. For the first time in living memory, scientists were forced to admit that the cosmos had just defied their most fundamental assumption. What made this even more unsettling was the sheer scale of the maneuver. Imagine a mountain-sized object suddenly shifting direction with the power equivalent to multiple Saturn V rockets firing at once. That's the kind of force recorded by observatories. And yet, when astronomers peered at 3I Atlas through the most powerful telescopes humanity has ever built, they saw nothing. No exhaust plume, no signs of chemical propulsion, no natural explanation whatsoever. This wasn't just a cosmic anomaly. It was a wake-up call. If an interstellar object can alter its own trajectory in such a precise and violent way, then something or someone must be in control. And if that's true, then humanity is no longer simply studying an ancient relic from deep space. We may be witnessing the actions of advanced technology billions of years old, a technology that understands and manipulates forces we cannot yet grasp. As the hours passed, the realization spread like wildfire through the global scientific community. Astrophysicists who had not slept in over 36 hours stared at their screens in disbelief. Emergency calls between NASA, ESA, and independent researchers filled the night air. The entire world had just witnessed the impossible, and the question was no longer whether 3I Atlas was a natural body. The question was why it had chosen this moment, this trajectory, to reveal capabilities far beyond anything humanity had ever encountered. Before we dive in, hit that subscribe button and turn on notifications. You don't want to miss any updates on the universe's deepest secrets. And if you love exploring hidden mysteries and unexplained discoveries, give this video a like so we know to keep uncovering them. When the 17-degree turn was first detected, scientists thought it had to be an error, perhaps a calibration fault, a software glitch, or interference in the instruments. But as the data poured in from multiple observatories across 3 continents, the impossible truth became undeniable. The readings were real. 3I Atlas had changed course with a level of force that defied every natural explanation. To understand how shocking this was, consider the raw numbers. Astronomers measured accelerations equivalent to firing off several Saturn V rockets simultaneously. These were the colossal launch vehicles that once carried astronauts to the moon, each capable of generating over 7.5 million pounds of thrust. Now imagine that power multiplied several times over, and instead of launching a 100-ton spacecraft, it was shifting an object 10 kilometers wide, the size of a small mountain, across the void of space. That is the kind of force 3I Atlas demonstrated in a single maneuver. Yet, when scientists pointed their most sensitive instruments at the object, there was nothing to see. No brilliant flare of energy, no jets of gas, no heat signatures or exhaust. Plumes that might explain the acceleration. In space, propulsion leaves clues. Even a comet adjusting course from outgassing, gases venting off its icy surface as it warms near the sun, produces visible trails, predictable pushes that can be measured and modeled. But here, the instruments found only silent. The energy was there, the movement undeniable, yet the mechanism behind it remained completely invisible. This left scientists with a chilling conclusion. If 3I Atlas could move in ways that mimic the raw thrust of rockets without leaving any detectable trace, then we were witnessing a process beyond known physics. Was it some kind of reactionless drive? A technology theorized but dismissed as impossible under our current understanding of momentum and energy? Was it manipulating gravitational fields in ways we cannot yet imagine? Or had humanity just encountered a form of propulsion designed to conceal itself, deliberately hiding its signature from any civilization advanced enough to watch? The lack of answers shook the scientific community to its core. NASA engineers who had built entire careers on the predictable laws of orbital mechanics suddenly faced equations that no longer worked. ESA's magnetometer readings, once designed to pick up the faintest whispers of a comet's field, were spiking off their charts. The numbers weren't just high, they were organized, patterned, as if some kind of system was actively controlling the field around the object. The comparison many researchers reached was unsettling. It was as though 3I Atlas was not a wandering relic, but a guided vessel. A vessel that could alter its own path with precision, without visible means, using forces humanity has not yet mastered, or even proven possible. For decades, the search for extraterrestrial intelligence has been speculative, relying on faint radio signals or distant anomalies in starlight. But here was something different, something tangible, something in motion. A vast interstellar traveler demonstrating physics that humanity cannot replicate, and perhaps cannot even comprehend. And perhaps most unnerving of all was the timing. Why now? Why reveal these capabilities only as it approached the inner solar system? Was this maneuver simply the activation of ancient automated systems, programmed billions of years ago? Or was it an intentional signal, a message written not in words but in movement, deliberately showing us that we are not the only intelligence in the cosmos with the ability to shape the stars to our will? The forces recorded were real, the physics behind them unknown, and the implications profound. 3I Atlas had shattered the illusion that space is predictable, and that objects move only where gravity allows them. Something extraordinary was happening, and humanity had no choice but to watch. The mystery of 3I Atlas deepened, not only because of its sudden maneuver, but also because of what it is made of, and how impossibly old it seems to be. The story began on July 1, 2025, when NASA's Atlas Sky Survey first detected a faint, fast-moving object cutting across the background stars. At first glance, it seemed to be just another interstellar traveler, much like Oumuamua in 2017 or Comet 2I Borisov in 2019. But within days, astronomers realized they were looking at something profoundly different, something that didn't fit any known category. Ordinary comets and asteroids from beyond our solar system carry a recognizable chemical signature. As they approach the Foribam, sun, ice, and frozen gases begin to sublimate, venting water vapor along with smaller amounts of carbon dioxide, methane, and other compounds. These reactions are predictable, and the ratios rarely change. But when spectrographs locked onto 3I Atlas, the readings were baffling. Instead of the expected water-rich plumes, this object seemed to breathe carbon dioxide, releasing it at a ratio nearly 8 times greater than water vapor. This wasn't a minor deviation, it was completely backwards from everything we've studied in thousands of comets across the solar system. Imagine watching a forest where the trees exhale smoke instead of oxygen. The behavior of 3I Atlas was that alien. The implications are staggering. A body exhaling carbon dioxide at such intensity suggests a structure or chemistry far removed from anything formed in our cosmic neighborhood. Some scientists have argued this points to an entirely different process of planetary formation, one that occurred around stars unlike our Sun. Others whisper something more provocative, that the ratios are artificial, engineered, or at least influenced by design, serving a purpose we cannot yet guess. And then there is the question of age. By analyzing its spectral signature and modeling the radiation damage imprinted across its surface, astronomers estimated that 3I Atlas may be more than 7 billion years old. To put that into perspective, our own Sun is only 4.6 billion years old. Much of the Milky Way's thick disk, the dense population of older stars orbiting above and below the galaxy's spiral arms, formed around 6 billion years ago. That means 3I Atlas predates not just the solar system, but vast swaths of the galaxy itself. It is older than Earth, older than the planets, older than many of the stars we see in the night sky. This object has traveled through regions of space our species can barely imagine, enduring cosmic collisions, stellar radiation, and gravitational slingshots over timescales that dwarf the entire history of life on Earth. And yet, despite its inconceivable age, it remains intact, functional, and active. How could something survive that long? If it is merely a natural fragment, then its resilience is unlike anything we've ever studied. If it is artificial, then its creators designed it to endure not just centuries or millennia, but billions of years of relentless cosmic wear. The carbon dioxide exhalations, the reversal of expected chemistry, and the evidence of extreme antiquity paint a picture that is both awe-inspiring and deeply unsettling. This isn't just another interstellar rock wandering through the solar system. This is a relic older than much of the galaxy, arriving at our doorstep as if on schedule. Its very composition is a message written in the language of chemistry, a message that says, "I am not from here. I am not what you think I am, and I have been traveling far longer than you can comprehend." As if the bizarre composition and impossible maneuver of 3I Atlas weren't enough, the next discovery pushed scientists even further into uncharted territory. It came from the sensitive instruments designed to read faint magnetic whispers across space. When astronomers turned these detectors toward the object, they expected weak, inconsistent signatures, the kind of scattered electromagnetic fluctuation comets naturally produce as they interact with solar radiation. Instead, what they found left entire research teams stunned. The readings weren't just high, they were off the charts, nearly 400% stronger than what a comet of this size and composition should ever emit. These were not background fluctuations or cosmic noise. They were structured, powerful, and consistent, as though something inside 3I Atlas was deliberately generating a magnetic field. Even more unnerving was the organization of these signals. Natural objects produce chaotic field, messy and unstable, shifting with the solar wind and the heating of their surfaces. But 3I Atlas displayed something very different. The field lines appeared clean, aligned, and sustained over time. It was as though the object wasn't just radiating magnetism, it was controlling it, shaping it into a shield or a grid. Researchers compared the patterns to those generated by Earth's magnetosphere, the invisible bubble that protects our planet from solar radiation. Except this was no planet, no spinning iron core driving the effect. This was a wandering interstellar body, ancient and alien, radiating a magnetic signature that seemed to have purpose. Some speculated it might be a defense mechanism, designed to protect the object from the harshest cosmic rays. Others suggested it could be part of a propulsion system, bending space or interacting with solar winds in ways humanity can't yet comprehend. What disturbed scientists most was the stability of the field. Over days of observation, the magnetic fluctuations repeated with almost mechanical precision, cycling in rhythms too orderly to be dismissed as coincidence. The data resembled not the erratic hum of a natural rock, but the steady pulse of an engineered machine. Telescopes around the world confirmed the findings. Independent teams from Hawaii, Chile, and South Africa all recorded identical results. And once again, emergency calls rippled across international borders. Physicists tried desperately to reconcile the evidence with existing theory, but the gap between what was expected and what was measured grew wider with each new reading. If 3I Atlas truly generates and manipulates its own electromagnetic field, then the implications are staggering. This would mean it carries technology, or embodies principles, that humanity has not only failed to replicate, but has barely imagined. Magnetic shielding, electromagnetic propulsion, or something even stranger. It all seemed possible. And beneath it all lingered a darker question. Why would an object traveling through interstellar space for billions of years need such a system? Was it purely for survival, to shield itself on its endless journey? Or was it designed to broadcast, to be found, to send a signal across the stars not in words, but in the unmistakable language of controlled energy? One thing became clear. The Atlas was not silent. It was speaking, through its movements, through its chemistry, and now through electromagnetic rhythms that looked less like the randomness of nature and more like the heartbeat of an ancient machine. For weeks, astronomers around the world had been puzzling over 3I Atlas's strange maneuvers, its alien chemistry, and its unnatural magnetic field. But nothing could have prepared them for what came next. It began quietly, almost unnoticed, when a team of radio astronomers in Puerto Rico, scanning the skies for background signals, noticed a faint, repeating transmission emanating from the object. At first, they assumed it was interference, perhaps a satellite in orbit, or the usual background chatter of human technology bouncing around Earth's atmosphere. But when independent observatories in Australia, South Africa, and Europe all confirmed the same signal coming from the same source, the truth was undeniable. 3. Atlas wasn't just moving strangely, it was speaking. The transmission repeated every 4.7 hours with uncanny precision. That alone suggested something extraordinary, because natural radio emissions, whether from pulsars, quasars, or comets, are irregular and noisy. But this wasn't noise, it was structure, it was order. When scientists broke down the patterns, they uncovered something unmistakable. The signal contained sequences of prime numbers, numbers divisible only by 1 and themselves. In mathematics, prime numbers are universal, a kind of cosmic language that transcends culture, biology, and even planets. They don't occur in random sequences in nature. They have to be constructed. And yet, here they were, encoded into the signal of a body that had traveled across interstellar space for billions of years. But that was only the beginning. Within the signal were constants woven like threads, values for pi, the speed of light, Planck's constant. These weren't just random bits of information. They were the fundamental truths of physics, the building blocks of reality itself. It was as though the sender of the signal had chosen the one language no intelligent species could misunderstand, the mathematics of the universe. And then came the most staggering revelation. Buried deeper in the signal was a form of data compression far beyond anything humanity has yet achieved. Our most advanced algorithms for reducing data, methods that allow vast amounts of information to be packed into tiny signals, look primitive compared to what was hidden in the transmissions of 3I Atlas. Some of the world's top cryptographers worked day and night, pulling apart the layers of encoding, and what they found left them speechless. The structure of the signal wasn't just efficient, it was elegant, as if written by minds who had mastered not just communication, but the very art of information itself. Every layer revealed more complexity, more intelligence, more evidence that this was no accident of physics. It was deliberate. It was intentional. For the first time in human history, scientists weren't staring at a possible artifact from afar or speculating about shadows on a distant star. They were listening to a voice, not a biological one, not even a spoken one, but a voice all the same. A voice from an intelligence older than Earth itself, carried across the stars for billions of years, now finally reaching us. The implications spread like wildfire. If the signal contained prime numbers, universal constants, and compressed information, then it wasn't just a beacon. It was a message. Something or someone wanted to be heard, and they had chosen 3I Atlas as their messenger. Around the world, astronomers, cryptographers, and physicists leaned closer to their screens, knowing that humanity had crossed a threshold. This was no longer about a strange rock defying gravity. This was contact. Real, undeniable contact with intelligence beyond our own. If the strange radio signals of 3I Atlas weren't enough to raise the alarm, the visual data pushed the mystery to a level no one could ignore. As the object drew closer to the inner solar system, high-resolution imaging became possible. Teams from NASA, ESA, and ground-based observatories combined their efforts, using every telescope available to capture its surface in greater detail. What they found shook even the most skeptical scientists. On the surface of 3I Atlas were not the rough, jagged scars of natural erosion. Instead, instruments revealed something profoundly unsettling. Geometric formations, vast hexagonal ridges, straight-edged patterns, and angular depressions sprawled across its terrain like the blueprints of a forgotten city. Nature, left to its own devices, tends toward chaos, fractured craters, irregular fissures, surfaces that bear the random violence of cosmic impacts. But here, geometry reigned supreme. Straight lines, repeating angles, and symmetry far too precise to dismiss as coincidence. It was as though the object had been carved, shaped, or built. Some observers described it as resembling the surface of a colossal machine, its structure functional rather than decorative. The patterns aligned in grids, as if serving a hidden purpose beneath the crust. And the deeper scientists looked, the stranger it became. Spectral analysis, the study of how materials reflect and absorb light, revealed metallic alloys embedded within the surface. These weren't the common iron or nickel compounds one might expect from asteroids. These were exotic blends, combinations of metals that do not occur naturally under any conditions we know. Alloys that, on Earth, can only be produced in controlled laboratory settings, requiring precise heat and pressure. Even more disturbing, some of these alloys showed properties that bordered on the impossible. They exhibited resistance to radiation, far beyond natural minerals, and heat tolerances that would allow them to survive the heart of a star. If these results were accurate, then humanity was looking at engineered materials, substances forged with intent, designed to endure conditions that nothing in our solar system could withstand. The combination of geometry and metallurgy left little room for doubt. This wasn't a random lump of rock wandering the galaxy. It bore the hallmarks of construction. Perhaps it was a vessel, perhaps a probe, perhaps something we have no words for yet. But whatever it was, it had been built by someone or by something. The reactions from the scientific community were divided between awe and dread. Some argued that the geometry could still be a trick of perspective, an illusion created by shadow and light. But as more scans confirmed the same patterns, that argument grew harder to defend. Others claimed the alloys might be the result of unknown cosmic processes. Yet even they struggled to explain why those metals were organized in such deliberate ways across the surface. If the object is artificial, then its very existence changes everything we thought we knew about the universe. It means intelligence arose long before humanity, advanced enough to craft a probe that could survive billions of years of interstellar travel. And now, that probe, shaped by alien hands and armored in impossible alloys, had chosen this moment to reveal itself in our skies. The message was no longer hidden in signals or chemistry. It was written into the very bones of the object itself. I was made, I was built, and I have come a very long way to be here. For months, scientists had tracked 3I Atlas with precise confidence. Its trajectory was calculated down to the smallest decimal point. its course projected to swing harmlessly past Mars and continue on into the outer solar system. The event was expected to be historic, yes, but safe, an opportunity to observe an interstellar visitor without any danger to our planetary neighborhood. But all of those assumptions shattered the moment 3I Atlas changed direction. Its violent 17-degree turn did more than shock physicists. It rewrote every prediction of where it would go. Instead of gliding past at a comfortable distance, the object was now set on a path that would carry it startlingly close to Mars. The new projections placed its flyby at just 2.7 million kilometers from the planet, closer than some of its own moon. The implications were immediate. Mars is not just a barren world to humanity. It is a hub of robotic exploration. Orbiters like MAVEN and the Mars Reconnaissance Orbiter circle the planet tirelessly, relaying vital data about its atmosphere, its geology, and even acting as communication relays for rovers on the ground. These machines represent decades of work and billions of dollars of investment. A sudden gravitational disruption or an unexpected debris field from 3I Atlas could put them all at risk. Inside NASA's Jet Propulsion Laboratory, control rooms filled with tense silence as simulations ran through every possible scenario. Could the object shed fragments under the stress of its maneuver? Could electromagnetic interference disrupt orbiters as it passed? Would Mars itself experience measurable effects from such a close approach? No one could say for certain, and uncertainty was the one thing scientists feared most. But where there is danger, there is also opportunity. For the first time in human history, a massive interstellar object, possibly even an engineered construct, was about to sweep close enough for high-resolution observation. Instruments designed to peer at Mars could now be turned toward 3I Atlas, capturing details no telescope from Earth could hope to resolve. If the timing and positioning were right, the orbiters could map its surface, probe its composition, and maybe even record the origin of its strange signals. The moment carried a sense of double-edged anticipation. On one hand, the risk was real. A near pass of this magnitude could alter the delicate balance of spacecraft orbiting Mars. On the other hand, it was a once-in-civilization chance to study an interstellar enigma up close. Scientists spoke of it in reverent tones, calling it the equivalent of sending probes to another star. Except this time, the star had sent something to us. As the flyby date approached, global space agencies faced difficult choices. Do they prioritize protecting their valuable orbiters, adjusting their positions to reduce risk? Or do they take the gamble of keeping them trained on 3I Atlas, hoping to capture data that might never be available again? The clock was ticking. The trajectory was locked, and the outcome remained uncertain. What was clear, however, was that humanity was about to witness something extraordinary. An interstellar traveler, older than our solar system, brushing past the red planet as though it had chosen to make its presence known in the one place. Humanity had already begun to reach. The risks were undeniable, but the opportunity was beyond measure. The signals of 3I Atlas had already astonished the world. Prime numbers, universal constants, compressed information far beyond our technology. But when cryptographers from MIT and NASA began tearing into the structure of those transmissions, they discovered something even more extraordinary. The signal wasn't just a single message. It was layered, like a cosmic puzzle box, each stage unlocking deeper and more complex information. At first, the data appeared to describe movement, rows of numbers, arcs, coordinates, star maps. It was MIT's astrophysics team that realized what they were looking at. This was a stellar navigation record, a logbook written across billions of years. The path of 3I Atlas stretched back more than 7 billion years, tracing a journey across the galaxy itself. It had passed through nebulae, skirted the edges of collapsing stars, and even drifted near regions of space where dark matter density warped gravity in ways humans had never directly observed. For the first time, humanity wasn't just guessing, about ancient galactic history. It was reading it, encoded in the language of an object that had been there. But this was only the first layer. The second was even more unsettling. Embedded within the transmissions were forecasts, maps of solar activity, magnetic storms, and stellar flares, predicted with an accuracy that bordered on the supernatural. The models were tested against Earth's own sun, and the forecasts proved correct 97% of the time, weeks in advance. Our best solar observatories struggle to predict such events with even half that accuracy. Yet, here was an object casually, handing humanity a predictive framework for stellar weather, as if it had been monitoring stars on its voyage and perfecting the science for eons. And then came the third layer, the deepest, most complex portion of the message. Cryptographers described it as a framework of equations, written in pure mathematics, building towards something humanity has long dreamed of but never achieved: a unified field theory. It appeared to connect the four fundamental forces of nature: gravity, electromagnetism, and the strong and weak nuclear forces into one seamless model. If confirmed, it would be the single most important scientific breakthrough in history, solving mysteries that have eluded generations of physicists. But the equations didn't stop there. They hinted at applications, technologies far beyond our reach, concepts of faster-than-light communication, mechanisms to manipulate space-time itself, and even diagrams resembling structures that could channel energy in ways no human engineer has ever designed. It was as if the signal contained not just knowledge, but a roadmap, instructions for civilizations ready to take their first steps beyond their own star. The discovery electrified the scientific world. Overnight, labs across the globe shifted their focus, pouring resources into analyzing the data. Governments, too, became deeply invested, some demanding secrecy, others calling for the information to be shared openly. Because if the message was real, if humanity could unlock even a fraction of what was hidden within those equations, then everything from energy to space travel would change forever. And yet, beneath the excitement was a haunting realization. This knowledge had been sent for a reason. Someone, or something, wanted humanity to have it. The layers of the signal weren't just a gift. They were a test, a measure of whether we were advanced enough to open them. And the deeper humanity looked, the more the question grew impossible to ignore. Why now? Why us? As scientists peeled back the layers of 3I Atlas's messages, a chilling realization emerged. The interstellar object wasn't just a passive messenger, a scientific probe, or a curiosity to study. It was something far more purposeful, far more urgent, a refugee beacon. Data embedded in the signals painted a picture of a civilization that had once thrived in a distant part of the galaxy, only to face annihilation, cosmic catastrophes, gravitational distortions, intense radiation zones, even pockets of destabilized space-time had forced them to flee their home star systems. These were not random disasters, but predictable, slowly propagating events that swept through regions of space with devastating precision. Humanity was witnessing a warning encoded in both signal and substance. The universe could be far more dangerous than we ever imagined. 3I Atlas itself was a survivor. Its complex structure, metallic alloys, and geometric architecture were not just for communication. They were designed to endure the unrelenting hazards of interstellar flight. It carried detailed information about these hazards, including navigational instructions, environmental readings, and predictive maps showing the movement of these galactic-scale threats. Essentially, it was a warning package, a cosmic survival kit, meant to reach civilizations capable of understanding and acting on it. But what stunned researchers most was the revelation that 3I Atlas was not alone. Signals suggested the existence of thousands of similar beacons scattered throughout the Milky Way. Each one functioned as part of an interstellar evacuation network, a web of autonomous lifeboats carrying knowledge and survival strategies across light years. Some had already passed through our solar system unnoticed, silently continuing their voyage to more distant sectors. Others were still on their way, carrying the experiences, warnings, and technologies of vanished civilizations. The implications were staggering. These beacons were not exploratory. They were lifelines, desperate attempts to preserve knowledge and intelligence in the face of cosmic extinction events. Humanity, for the first time, was confronted with a galaxy alive with the footprints of intelligent life, not just in existence, but in flight. These were survivors speaking across eons, leaving messages encoded in mathematics, physics, and material science, hoping someone or something would listen. The realization also brought unease. If advanced civilizations had been forced to scatter, to flee annihilation, what threats might one day reach our solar system? Were we glimpsing a future that could one day include Earth? And yet, within the fear lay opportunity. Humanity had the chance to learn from these refugee probes, to understand not just the cosmos, but the strategies needed to survive in it. The beacons were both a warning and a gift, an invitation to ascend beyond planetary limits. Atlas, once thought to be a wandering comet, had revealed its true purpose. A messenger of survival, a cosmic refugee carrying the wisdom of civilizations, long gone, and the instructions for navigating a perilous universe. Its journey was far from over, and its revelations were only beginning. The revelations of 3I Atlas spread like wildfire. Initial attempts at suppression by governments and intelligence agencies were quickly overwhelmed. Leaks, open-access publications, and the vigilance of amateur astronomers made secrecy impossible. The data was out in the open, streaming across scientific networks, news outlets, and online forums, sparking a global debate. What did it mean for humanity's future? The messages were stark and unflinching. The interstellar civilization that had sent 3I Atlas left behind a warning encoded in every calculation, every pattern, and every layer of transmitted data. Single-planet civilizations face near-zero odds of long-term survival. Entire species had vanished because they were confined to their home worlds, unable to adapt to the cosmic-scale hazards that silently traverse the galaxy. Humanity, for the first time, was forced to confront a truth far more urgent than climate change, nuclear proliferation, or pandemics. Our survival depended not on politics, but on reaching beyond the cradle of Earth. Scientific organizations rapidly shifted priorities. Space agencies, previously limited by budgets and politics, now collaborated at unprecedented levels. Engineers, astrophysicists, and materials scientists worked side by side to explore technologies once relegated to science fiction. Massive space habitats capable of sustaining human populations off-planet, propulsion systems that could move, entire fleets across interstellar distances, and shielding methods that could protect against radiation bursts, gravitational anomalies, and destabilized space-time zones. The clock was ticking, and every year counted. Beyond technology, the cultural and philosophical impact was profound. Humanity began to see itself not merely as inhabitants of a single world, but as potential participants in a broader galactic civilization. Educational systems introduced cosmic survival strategies, while political leaders faced pressure to invest in initiatives previously considered speculative. Entire industries pivoted toward interstellar research, from advanced AI for autonomous spacecraft to materials capable of surviving decades in the harsh interstellar medium. Yet urgency was tempered with uncertainty. How long before these galactic-scale threats reached our neighborhood? The data implied decades, not centuries. A tight window for a species that had barely scratched the surface of space exploration. Every decision mattered. Every misstep could be irreversible. The 3I Atlas messages were both a lifeline and a challenge. Humanity had the knowledge, but could it rise to meet the scale of the threat? As the world watched, the message became clear. Humanity had reached a crossroads. One path led to complacency, confinement, and eventual extinction. The other required courage, cooperation, and ingenuity on a scale never before demanded of our species. 3I Atlas was no longer just an interstellar object. It was a cosmic wake-up call. The question now was whether we would answer it in time. The choice was ours, and the clock was ticking. As 3TU Atlas continues its silent voyage through the galaxy, humanity stands at the edge of a new era. The object itself drifts farther from our sun, a metallic and geometric sentinel carrying the knowledge and warnings of a civilization that survived against impossible odds. It is a reminder that intelligence, curiosity, and foresight can persist even when entire worlds vanish. Around the globe, humans are beginning to act. Space habitats are in early construction, propulsion systems are being tested, and shielding. Technologies are advancing faster than anyone thought possible. The seeds of interstellar civilization are being planted, not for conquest, not for glory, but for survival. And yet, the ultimate question remains unanswered. Will humanity rise to meet the cosmic challenges that 3I Atlas has revealed, or will we remain confined to a fragile planet, unprepared for the dangers that move silently across the stars? The probe drifts onward, indifferent to our success or failure, a messenger of both hope and warning. Its journey is a reminder that the universe is vast, ancient, and full of mysteries, and that survival demands vision, courage, and unity. In the end, the legacy of 3I Atlas may not be the secrets it carries, but the spark it ignites in humanity. The realization that our fate is not written by the stars alone, but by what we choose to do with the knowledge they leave behind. And as we look to the sky, we are reminded that, for the first time in history, we are not just observers of the cosmos. We are participants. If you found this journey through hidden science, cosmic secrets, and potential alien infrastructure as mind-blowing as we did, make sure to subscribe and hit the notification bell. Don't miss future explorations into the universe's deepest mysteries, because some secrets are just waiting to be uncovered. Here's a fact that should keep you awake at night. There's currently an object in our solar system with a 1 in 10,000 probability of occurring naturally. Yet, here it is, defying the laws of physics as we understand them. I Atlas has been observed by multiple observatories worldwide, and every single one confirms the same impossible reality. This thing has a tail that acts more like rocket exhaust than cosmic dust. In the next few minutes, we're going to break down exactly why NASA's own data suggests this might not be a natural object at all, and what that could mean for humanity's future. On the night of July 1st, 2025, astronomers scanning the skies picked up something extraordinary. At first, it looked like just another faint streak of light against the background stars. But within hours of tracking, it became clear this was no ordinary visitor. The object was moving at nearly 130,000 miles per hour. That's faster than anything bound to the sun could travel. For comparison, Earth orbits at just under 70,000 miles per hour. This thing was moving almost twice that speed, cutting through the solar system like a bullet. As data poured in, scientists realized its orbital eccentricity was greater than 6. To put that into perspective, any eccentricity above 1 means the object is not bound to the sun at all. It isn't looping back. It isn't returning. It's on a one-way journey. A true interstellar traveler. This placed the object in an incredibly rare category. Only 2 others in history have ever been observed crossing through our solar system from the stars beyond. The first was in 2017, the mysterious Oumuamua, which sparked endless debates about its shape, its acceleration, and even its possible artificial nature. The second was Comet Borisov in 2019, which behaved much more like a typical comet. And now, in 2025, we have the third, catalogued as 3I Atlas. a new interstellar interloper. But unlike its predecessors, 3II Atlas would quickly reveal itself to be even stranger, even harder to explain, and far more unsettling. From the moment it was first tracked, scientists knew they were dealing with something unprecedented. Its speed alone was shocking. At nearly 60 kilometers per second, it was traveling fast enough to cover the distance from Earth to the Moon in just over an hour. That's cosmic lightning. But beyond speed, there was something else that made astronomers sit up straight: its trajectory. 3I Atlas wasn't coming in from some random angle across the galaxy, like most interstellar debris should. Instead, it entered our solar system on a path nearly aligned with Earth's orbital plane, within just a few degrees of the ecliptic. The odds of such a perfect alignment happening by chance are vanishingly small. In the weeks following its detection, telescopes around the world began locking on to this strange object. And the deeper they looked, the more unsettling the picture became. What at first seemed like a faint comet soon began breaking every rule astronomers thought they understood. Atlas wasn't just another rock from deep space. It was something altogether different. Something that defied the patterns of nature we've come to expect. And as the days ticked by, it became clear. This was the start of one of the greatest astronomical mysteries of our time. When most people imagine a comet, the picture is clear. A glowing head trailing a sweeping tail of gas and dust, pushed outward and away from the sun by solar radiation, and the constant stream of charged particles we call the solar wind. This is a universal rule. No matter where a comet comes from, no matter what its size or composition, its tail always points away from the sun. That's basic physics. Before we dive in, hit that subscribe button and turn on notifications. You don't want to miss any updates on the universe's deepest secrets. And if you love exploring hidden mysteries and unexplained discoveries, give this video a like so we know to keep uncovering them. But 3I Atlas refused to play by the rules. When telescopes zeroed in on the object, astronomers were stunned to see something no one had ever witnessed before. Its plume, its so-called tail, was not streaming outward into the darkness. Instead, it was pointing directly back toward the sun. Think about that for a moment. Against the powerful force of solar radiation, against the relentless push of the solar wind, this object seemed to be doing the impossible. Its material wasn't being blown away. It was flowing inward, in the exact opposite direction, and it wasn't just a faint anomaly that could be brushed off as an error in observation. The plume was narrow, sharply defined, and completely stable. Night after night, as different observatories turned their instruments toward 3I Atlas, the same result appeared: a jet that looked nothing like a comet's tail, and everything like something else entirely. Comet tails are diffuse. They spread out. They shimmer and shift under the sun's energy. But this was different. 3I Atlas's plume held its shape with remarkable precision, more like a beam than a cloud. Instead of dispersing into space, it cut a clear, straight line, as if directed, as if controlled. For many astronomers, the implications were disturbing. Nature doesn't usually draw such clean lines. If this was truly a natural comet, it was breaking every known pattern. And if it wasn't natural, then what exactly were we looking at? The discovery of the sunward plume marked a turning point. It was the first undeniable sign that 3I Atlas wasn't going to fit neatly into any existing category. The object wasn't behaving like Borisov, the icy interstellar comet of 2019, nor was it mimicking Oumuamua, which showed no tail at all but still managed to accelerate mysteriously. Instead, 3I Atlas was carving out its own mystery, one that challenged the very foundation of how scientists understood comets. At this stage, the questions began piling up faster than the answers. What kind of physics could drive a plume against the sun's energy? What force could generate such a focused, consistent jet? Was it simply an exotic chemical reaction, or could it be something far more deliberate? As days passed, what had seemed like a curiosity was quickly becoming a crisis for comet science. And the closer astronomers looked, the stranger it became. When an observation challenges the foundations of science, the first response is always skepticism. Could this sunward plume be an error? A trick of the telescope? A glitch in the processing software? To test it, astronomers around the globe turned their most powerful eyes to the sky. The Hubble Space Telescope was among the first to lock onto 3I Atlas. Floating high above Earth's atmosphere, Hubble has given us some of the clearest images of comets in history. And when its instruments recorded the plume, there was no mistaking it. The tail was there, narrow, defined, pointing in the wrong direction. Next came Gemini South, perched on a mountain peak in Chile, one of the finest ground-based observatories on the planet. Its massive mirror confirmed the same sight. No matter how carefully they checked their equipment, the data was undeniable. The jet of 3I Atlas was flowing inward, back toward the sun. Then came a third confirmation, from the Lowell Observatory in Arizona, a historic facility that has watched the skies for over a century. Once again, the results were identical. The plume was real. 3 different instruments, 3 different locations, weeks apart, and every single one told the same story. Even more unsettling, the plume wasn't fading, shifting, or breaking apart the way a normal comet tail would. It persisted. Night after night, week after week, the narrow jet held steady. It didn't disperse into a broad fan of dust. It didn't curve under the pressure of solar radiation. It behaved like a controlled stream, aimed with precision, utterly unlike any natural plume ever recorded. For the scientific community, this was the moment when doubt began to turn into unease. A single observation can always be dismissed. But when multiple world-class observatories, each using different instruments and techniques, all confirm the same impossible phenomenon, it becomes something else. A pattern, a mystery that refuses to go away. By this point, the whispers began. Could this object be something other than a comet? Could it be a machine? A probe? Some kind of interstellar technology that uses directed exhaust to steer its course? The official explanations tried to keep things grounded. Perhaps it was a chemical plume, produced by some exotic volatile that reacted strangely under the sun's heat. Perhaps. But the longer the plume persisted, the less convincing those answers became. Because comets don't hold steady like this. Nature doesn't fire clean beams into space. And yet, 3I Atlas did. The confirmation from Hubble, Gemini, and Lowell left astronomers with no escape. This was real. It was happening. And whatever 3I Atlas was, it wasn't going to fit neatly into any natural category we'd seen before. Once the plume was confirmed as real, the next question became obvious. What exactly is it made of? For that answer, astronomers turned to the most advanced tool available, the James Webb Space Telescope. Webb's powerful spectrographs can break down the faint light reflected and emitted by objects in space, separating it into a chemical fingerprint. From that fingerprint, scientists can tell which molecules are present and in what amounts. When Webb analyzed the light from 3I Atlas, the results stunned researchers. The ratio of carbon dioxide to water was unlike anything ever seen before. In ordinary comets, the ratio might be 1:1, sometimes lower. But here, the numbers were extreme. Nearly 8 parts carbon dioxide for every 1 part water. This was a chemical imbalance that didn't match anything we've studied within our solar system. No comet from the Oort cloud, no asteroid fragment, no icy body from the Kuiper belt has ever shown such an overwhelming dominance of carbon dioxide. But that wasn't all. The analysis also revealed something even stranger. Nickel was present in the spectrum, a metal found in many cosmic bodies, but iron was missing. On Earth and throughout the solar system, nickel and iron almost always appear together. They form in the same processes, locked side by side in meteorites, asteroids, and planetary cores. To find one without the other is deeply unusual, almost unnatural, together. These findings painted a picture of a body whose composition doesn't resemble anything we've ever cataloged in our cosmic neighborhood. It wasn't just an odd comet. It wasn't just an icy fragment with peculiar chemistry. It was something entirely different, as though it had been forged under conditions far outside what the solar system could produce. For some scientists, The results sparked speculation that 3I Atlas could have formed in an exotic stellar nursery, a place with chemical balances completely unlike our own. For others, the anomalies raised a more unsettling thought. Could these chemical signatures be the byproduct of technology, of processes not entirely natural? Because here's the puzzle. Comets vent material in chaotic plumes, a messy mix of gases and dust. But 3I Atlas was releasing a controlled, narrow jet, one dominated by carbon dioxide, reinforced by nickel, and conspicuously lacking iron. It's the kind of imbalance you might expect if someone was selecting materials for a purpose. By now, the mystery was growing darker. First came the impossible plume. Then came the confirmation that it wasn't an illusion. And now, the chemical fingerprint revealed that 3I Atlas was no ordinary traveler. Whatever it was, it didn't come from anywhere we know. As astronomers traced the path of 3I Atlas through the solar system, the story became even stranger. Not only was its speed extraordinary and its chemistry alien, but its trajectory defied the odds in ways that set off alarm bells. Instead of diving into our system at a random angle, as you might expect from an interstellar wanderer, 3I Atlas entered on a path that lay almost perfectly aligned with the ecliptic plane, the thin, flat disk where all of the planets orbit the Sun. The angle of alignment? Within just 5 degrees. That might not sound unusual at first, but the probability of such a match happening by accident is vanishingly small. Interstellar objects should come from anywhere, from all directions in 3-dimensional space. For one to slip into our system on a path so neatly in line with the orbits of our planets is like throwing a dart across a football field and landing it on the edge of a coin. But the strangeness didn't stop there. As orbital simulations were run forward, another shocking detail emerged. On its journey, 3I Atlas would pass remarkably close to not 1, not 2, but 3 major planets: Mars, Venus, and Jupiter. Think about how unlikely this is. Space is vast. Planetary orbits are wide apart. The odds of a random interstellar body threading its way through the solar system in such a way that it intersects with multiple planets are infinitesimal. Yet 3I Atlas seemed to be on a course that did exactly that. First, a near approach to Mars, the red planet, humanity's next frontier. Then a pass by Venus, Earth's closest neighbor. And later, an encounter with the giant Jupiter, the king of the planets, whose immense gravity shapes the architecture of the solar system. For some astronomers, this sequence raised unsettling possibilities. Could it really be a coincidence, or was this path chosen, designed? If 3I Atlas were some kind of craft or probe, its trajectory looked eerily like a planned tour, a path that maximized planetary encounters. Even those committed to natural explanations admitted the alignment was strange. Normally, interstellar comets are one-time visitors that barrel through space on erratic paths, indifferent to the layout of the planets. But 3I Atlas was behaving differently. Almost as if it were aware of the solar system it was entering, this improbable orbit only deepened the mystery. A plume pointing in the wrong direction was one thing, unusual chemistry was another. But now, the very course of the object itself looked suspicious. Was it a coincidence beyond comprehension? Or was there intention hidden in the math of its trajectory? One thing was certain: the more astronomers studied 3I Atlas, the harder it became to explain as just another rock from deep space. As the days turned into weeks, astronomers began to notice something even more disturbing about 3I Atlas. It wasn't just its plume, or its bizarre chemistry, or even its improbable trajectory. It was the way the object was moving. Careful astrometric tracking revealed that 3I Atlas wasn't following the precise path dictated by gravity alone. Instead, it was experiencing an extra push, a tiny but measurable force that was steadily accelerating the object beyond what gravity and inertia could account for. The numbers were precise. The extra acceleration measured at roughly 4 × 10 to the -7 meters per second squared. That might sound small, almost negligible, about the weight of a feather pressing against your hand. But in the vacuum of space, acting on an object for weeks and months. Even such a faint force adds up to enormous changes in trajectory. Now, comets are known to sometimes show what's called non-gravitational acceleration, caused by jets of gas erupting from their surfaces. But those outgassing events are chaotic and unpredictable. One jet might flare on one side of the nucleus, then fade. Another might erupt from a different location, sending the comet wobbling in new directions. The effect is irregular, messy, and inconsistent. Atlas, however, was different. Its acceleration was steady. The direction of that push was not random. It was always aligned perfectly with the plume. The same plume that pointed back toward the sun, cutting a narrow line of exhaust through space. This was not chaos. This was control. To scientists, the implications were chilling. A natural comet should not accelerate this way with such stability. The physics didn't fit. The only things we know of that produce steady directional thrust are engines, machines built to control motion. Could 3I Atlas really be demonstrating propulsion? Was this not a comet at all, but something designed to maneuver, to adjust its path with precision? For many, the comparison was impossible to ignore. The plume looked less like dust or gas, and more like the exhaust of an ion thruster, the kind of technology humanity itself has experimented with in deep space probes. And the numbers matched. The gentle but steady acceleration was exactly the kind of profile you'd expect from an ion drive. Small in the moment, but relentless over time. At this point, the mystery of 3I Atlas had escalated beyond curiosity. Its plume was wrong. Its chemistry was alien. Its orbit was improbable. And now its very motion suggested it might be under power. Nature does many strange things. But nature doesn't hold a steady course against the sun with a clean, consistent thrust. That's the behavior of a machine. The question was unavoidable. Had humanity just witnessed the first undeniable evidence of interstellar technology? The deeper astronomers looked into the behavior of 3I Atlas, the more they were struck by one inescapable comparison. Its plume, narrow, steady, and perfectly aligned with its acceleration, looked nothing like the diffuse dust tails of natural comets. Instead, it bore a startling resemblance to something humans themselves had only recently begun to experiment with: the ion thruster. Ion propulsion works very differently from the fiery rockets that launch spacecraft from Earth. Instead of explosive chemical reactions, an ion drive generates thrust by accelerating charged particles, usually xenon gas, through an electric field and ejecting them in a narrow, collimated stream. The result is not a violent push, but a gentle, steady force. One so weak that you could hold your hand in front of it without feeling a breeze. Yet in the vacuum of space, applied constantly over weeks and months, that feather-light thrust builds speed in ways that chemical rockets never could. And here was 3I Atlas, behaving in exactly that way. Its extra acceleration was faint, but consistent. It always pointed in the same direction as the plume. And most telling of all, the plume itself was sharply defined, not spreading out chaotically like cometary gas, but forming a tight beam, the hallmark of an engineered exhaust. For planetary scientists, the similarities were chilling. The numbers didn't just line up vaguely, they matched almost perfectly the thrust-to-mass ratios expected of known ion drives. It was as if the object were using a technology humanity already understood, only on a scale and efficiency far beyond anything we had yet built. This comparison raised the most profound of questions. Was 3I Atlas not a natural interstellar visitor at all, but a controlled craft? One capable of adjusting its path through deliberate propulsion? Was its improbable trajectory through the solar system not a coincidence, but the result of careful navigation, a plotted course designed to intersect with planets along the way? If true, it would mean that for the first time in history, humanity was not merely observing a rock from another star. We were watching technology, a machine from the depths of interstellar space. For some researchers, the implications were staggering. Either we had grossly misunderstood the physics of comets, or we were witnessing something artificial. And given the evidence, the plume, the chemistry, the improbable orbit, and now the acceleration, the artificial explanation was becoming harder to dismiss. It was as if the cosmos had just whispered, "You are not alone." As the anomalies of 3I Atlas mounted, the astronomical community found itself at a crossroads between two radically different explanations. On one side were the conservative scientists, grounded in centuries of experience studying comets. Their argument was simple. Maybe this object was unusual, but it was still natural. The presence of supervolatile ices, primarily carbon dioxide, offered a plausible explanation. CO2 can sublimate, turn directly from solid to gas, even far from the sun, producing jets of material. If these jets were concentrated in specific areas of the nucleus, perhaps due to rotation or surface irregularities, they could conceivably account for the sunward plume and the measured acceleration. In this view, 3I Atlas was just a comet behaving in a highly unusual way, an outlier but still governed by natural physics. Yet the opposing camp, led by figures like Harvard astrophysicist Avi Loeb, proposed a far more provocative interpretation. Loeb suggested that the precise alignment of the plume, combined with the steady non-gravitational acceleration, could indicate artificial propulsion. In other words, the object might not be a comet at all, but a probe from another star system, intentionally braking or maneuvering as it passed through our solar system. This debate immediately brought to mind the famous case of Oumuamua, the first confirmed interstellar object in 2017. Like 3I Atlas, Oumuamua displayed subtle accelerations that couldn't be fully explained by outgassing or radiation pressure alone. While most astronomers leaned toward natural explanations, a small but vocal group speculated about artificial origins. That discussion had shaken the community and forced astronomers to re-examine long-held assumptions about interstellar visitors. With 3I Atlas, the stakes were higher. The plume's direction, the chemistry dominated by CO2, the nickel signature, the improbable trajectory, and the consistent sunward acceleration all combined to make the artificial hypothesis harder to ignore. Unlike Oumuamua, this object also had direct visual evidence of its unusual plume, reinforcing the possibility that something more than natural processes was at play. Yet even for proponents of the artificial theory, caution was necessary. Nature is capable of extraordinary surprises. Perhaps there was a mechanism for sunward jets we hadn't discovered yet. Or maybe the nucleus contained pockets of volatile material perfectly, positioned to mimic engineered thrust. The tension between these two views, natural versus artificial, is what makes 3I Atlas so compelling. Each new observation challenges assumptions and forces scientists to ask uncomfortable questions. Could we be seeing technology from another civilization? Or is this just a reminder of how little we truly understand about interstellar objects? Regardless of the answer, one fact was clear. 3I Atlas had reignited a debate that extended far beyond comet science. It was a test of imagination, physics, and humility, reminding humanity that the universe may hold objects and phenomena far stranger than we ever anticipated. To understand the mystery of 3I Atlas, astronomers looked back at the history of interstellar visitors. Each one told a story, and each shaped the lens through which scientists now viewed this new object. The first confirmed interstellar object, Oumuamua, appeared in 2017. Its discovery electrified the scientific world, not just because it came from another star, but because of the strange behavior it exhibited. Oumuamua was elongated, tumbling end over end, and moving faster than anything bound to the sun. Most intriguingly, it accelerated slightly but consistently as it left the inner solar system, an effect that defied standard gravitational modeling. There was no visible tail, no detectable outgassing, and no clear explanation. Some scientists speculated it could be a fragment of ice or an asteroid from another system, while others, like Avi Loeb, suggested it could be a thin, sail-like object, possibly artificial. Oumuamua became a touchstone for what might be possible, a warning that interstellar visitors don't always follow the rule. Then, in 2019, Borisov arrived, Unlike Oumuamua, Borisov behaved like a classic comet. It sprouted a textbook tale, outgassed water and cyanide, and followed predictable physical laws. For astronomers, Borisov was reassuring. Interstellar objects could be both strange and familiar. The case of Borisov provided a baseline. Interstellar objects could be messy, icy travelers like the comets we knew, moving along their solar-bound trajectories without mystery. And now, in 2025, came 3I Atlas, challenging every expectation. This object was a hybrid of sorts. It had a visible tail, like a comet, yet that tail defied cometary physics. It pointed toward the sun, held its shape for weeks, and correlated with a non-gravitational acceleration. Its chemistry was alien, with a CO2 to H2O ratio 8 times higher than typical comets, plus the unusual presence of nickel without iron. The trajectory was improbable, threading past 3 planets with almost surgical precision. The parallels were striking. Oumuamua forced scientists to confront the unknown. Borisov reminded them of the familiar, and 3I Atlas blurred the line between natural and engineered. Each interstellar visitor added a layer of complexity, showing that the cosmos doesn't follow human expectations, and that interstellar objects may come in forms we have yet to imagine. For planetary scientists, these historical cases aren't just academic footnotes. They shape how we design observatories, how we model trajectories, and how seriously we consider the possibility of artificial objects. 3I Atlas isn't an isolated curiosity. It is part of a continuum, a growing catalog that demands new thinking and sharpens the tools needed to track the truly strange. In a sense, 3I Atlas is standing on the shoulders of its predecessors, but it also raises a new level of urgency. The universe may be teeming with interstellar visitors, and each one could challenge our understanding of physics, chemistry, and perhaps even technology itself. As 3I Atlas hurtles through the inner solar system, astronomers are now focusing on a moment of profound significance. October 30th, 2025, its perihelion passage. This is the point in its orbit where it comes closest to the Sun, reaching its maximum speed and experiencing the strongest solar gravitational forces. But perihelion carries an added complication. From Earth's vantage point, the object will pass directly behind the Sun, entering what is known as a solar conjunction. During this period, no telescope on Earth can see it. The Sun's glare overwhelms all optical instruments. Radar signals are drowned out by solar plasma, and even near-Earth orbiting observatories lose the ability to track the object. For weeks, 3I Atlas will effectively vanish, hidden behind the solar disk, creating a blind spot in one of the most critical windows of its journey. Why does this matter so much? Because if 3I Atlas is behaving like a natural comet, this period coincides with the peak of solar heating. Any sublimation of volatile ices, carbon dioxide, water, or even exotic supervolatiles would be at its maximum intensity, producing jets or outbursts that could alter the tail, the brightness, or even the trajectory. But if the plume is a sign of controlled propulsion, this is the ideal moment for a maneuver. A well-timed burn during perihelion could adjust its orbit subtly yet significantly, taking advantage of the Oberth effect, where propulsion at the point of highest speed produces maximal change in velocity. Astronomers are uneasy because there's no way to confirm what's happening in real time. Any sudden acceleration, directional change, or alteration in the sunward plume would go unseen until the object emerges from behind the Sun weeks later. Every subtle anomaly observed before perihelion, the plume's stability, the non-gravitational acceleration, the unusual chemistry, now carries heightened stakes, because it may be part of a critical phase where the object's behavior is at its most decisive. For planetary defense teams and dynamicists, this is a tense moment. They are preparing for every eventuality, modeling potential paths, simulating how minor forces could magnify during perihelion, and tracking the pre-conjunction acceleration data with unprecedented precision. The goal is simple. When 3I Atlas reappears, any deviation from predicted motion, Any change in the tail's morphology could provide clues about its true nature. In short, October 30th is more than just a date on the calendar. It is the ultimate test. Nature could reveal an extreme outgassing event, or the object could perform a maneuver that challenges all natural explanations. For weeks, humanity will watch and wait, suspended in a combination of wonder, uncertainty, and apprehension, knowing that what happens behind the sun may rewrite our understanding of interstellar visitors forever. Irish Atlas is a mystery unlike any interstellar visitor before it. Its sunward plume, unusual chemistry, and precise trajectory defy expectations and challenge our understanding of comets and natural objects. Perihelion behind the sun adds suspense, as any decisive activity will go unseen until it re-emerges. Whether natural or extraordinary, Three-Eye Atlas reminds us that the universe is unpredictable and full of surprises. Each new interstellar object expands our knowledge, sharpens our tools, and fuels curiosity. When it reappears, it may reveal answers, or raise even more profound questions about the cosmos. If you found this journey through hidden science, cosmic secrets, and potential alien infrastructure as mind-blowing as we did, make sure to subscribe and hit the notification bell. Don't miss future explorations into the universe's deepest mysteries, because some secrets are just waiting to be uncovered. What if I told you that the James Webb Space Telescope just shattered everything we thought we knew about Oumuamua, the mysterious interstellar visitor that baffled scientists in 2017? For years, we've been told it was just a cigar-shaped rock, tumbling through space. But the first real detailed images from JWST reveal something far more extraordinary and potentially disturbing. The object's prismatic, crystal-like structure, its impossible material composition, and its eerily perfect rotation are raising questions that challenge our understanding of natural space objects. Some of the data is so unusual that scientists are quietly discussing possibilities they never thought they'd have to consider. In 2017, astronomers around the world were stunned when telescopes in Hawaii detected something completely unprecedented. A small, fast-moving object shot through our solar system, but unlike anything ever catalogued before, its trajectory proved it didn't originate here. It came from far beyond, from the vast interstellar void. This visitor was given the name Oumuamua, meaning a messenger from afar arriving first in Hawaiian. For years, scientists struggled to understand what it truly was. The only tools available back then were limited: ground-based telescopes, faint light curves, and infrared readings that provided only the vaguest outline. The images were blurry, indirect, and left more questions than answers. Was it a comet without a tail? A strange asteroid? Or something entirely new? For half a decade, the mystery deepened. Countless theories emerged, from exotic natural formation to bold suggestions that Oumuamua could be artificial in origin. But there was one huge problem. No one had ever seen it clearly. Humanity had no true picture of this visitor until now. Enter the James Webb Space Telescope, the most advanced eye humanity has ever placed in space. Stationed 1 million miles from Earth, Webb's instruments are designed to peer deeper into the universe than anything before it. But when scientists turned its gaze not at distant galaxies, but at Oumuamua, history was made. For the very first time, we weren't looking at guesses, sketches, or artist renderings. We had a real, high-resolution image of an interstellar object passing through our neighborhood. What Webb revealed was breathtaking. No longer just a speck of light, Oumuamua appeared in full detail. Its surface, its shape, its very character came into view. This wasn't just science. It was a historic moment, the first time humanity captured the face of a visitor from another star system. The implications of that single image cannot be overstated. It marked the end of speculation based only on shadows and signals, and the beginning of direct observation. For astronomy, it was like stepping into a new era overnight. The James Webb image doesn't just show us an object. It shows us that we are not isolated. Our solar system is not a sealed-off bubble. Matter, fragments, and perhaps even the seeds of life itself move between the stars, and Oumuamua is proof of that journey. What Webb delivered was not simply a picture, but a window into the vast interstellar network that connects us to distant worlds. When Oumuamua was first discovered in 2017, the limited data made astronomers think it was elongated, a strange, cigar-shaped rock tumbling end over end through the solar system. This unusual assumption captured the public imagination. After all, nothing in our own asteroid belt, or Kuiper belt, looked quite like that. It was long, thin, and unlike the round or potato-shaped worlds we were used to seeing. For years, the cigar image became the face of Oumuamua, endlessly reproduced in documentaries, articles, and speculation. Before we dive in, hit that subscribe button and turn on notifications. You don't want to miss any updates on the universe's deepest secrets. And if you love exploring hidden mysteries and unexplained discoveries, give this video a like so we know to keep uncovering them. But now, thanks to the James Webb Space Telescope, that picture has completely changed. Webb's powerful instruments have given us the most detailed look yet, and what it shows is far stranger than anyone could have imagined. Instead of a smooth, elongated rock, Oumuamua appears as a prismatic, faceted structure. Imagine a shard of crystal or an angular fragment of glass with flat planes that catch and reflect light in sharp, geometric ways. That is what Webb has revealed. This geometry is deeply unusual. Objects in space rarely form with flat surfaces or sharp angles. Natural processes tend to create curves, spheres, ellipses, and irregular lumps worn down by collisions or erosion. But Oumuamua defies those expectations. Its sides seem to meet in edges, its surfaces gleam in facets, and it looks more like something fractured or carved than something naturally rounded. To some scientists, this prismatic shape hints at an origin very different from a normal asteroid or comet. Even more mysterious, these angular planes reflect light in an odd, almost crystalline manner. As Oumuamua rotates, the brightness we see doesn't match what a typical rocky or icy body would show. The reflective qualities are inconsistent with a simple hunk of stone drifting through space. Instead, they suggest materials that interact with light in unusual ways, perhaps metals, exotic ices, or even layered composites we don't fully understand. This discovery reignites a profound question. Could Oumuamua be a fragment of something larger? Perhaps it once belonged to a shattered planet, where violent collisions created crystalline shards that drifted into interstellar space. Or perhaps it is the remnant of some completely unknown cosmic process, one we've never seen before. And for some, the clean lines and angular form fuel a far bolder speculation that this geometry could be the hallmark of intentional design, as if this shard was once part of a structure, crafted rather than born. What makes this all the more fascinating is how it challenges our categories. We've always divided objects into neat boxes: comets, asteroids, dwarf planets. But Oumuamua doesn't fit. Its prismatic body is a new entry in the cosmic catalog, a shape that forces scientists to ask whether we've underestimated the diversity of interstellar objects, or whether we've just glimpsed something beyond the natural. If the shape of Oumuamua was already shocking, what James Webb discovered on its surface was even more bewildering. Using its powerful infrared and spectrographic instruments, Webb didn't just capture light bouncing off the object. It broke that light down into its chemical fingerprints. These spectral signatures revealed exactly what Oumuamua is made of, and the results were unlike anything we've ever seen in a natural interstellar body. The data showed a bizarre patchwork of materials spread across its surface. Certain regions reflected like polished metal, shining with the sharp brightness of reflective compounds and frozen ices. Yet just next to those gleaming surfaces were zones that seemed to swallow light, carbon-rich and almost pitch black, absorbing nearly everything that touched them. It was a striking contrast, as if the object were wearing two completely different faces at once. Even more puzzling, Webb picked up iridescent areas, surfaces that shimmered in changing colors, depending on the angle of the light. This phenomenon is rare in space. Iridescence usually requires layered or crystalline materials arranged in a precise way, like the shifting sheen of an opal or the rainbow glint on a soap bubble. For something drifting alone between the stars, that kind of surface effect is highly unexpected. And then there were the ices. Not ordinary frozen water, but exotic ices formed of molecules that, under normal circumstances, shouldn't be found together. Some appeared to be the kinds of volatile compounds we'd expect only in the deep freeze of interstellar space. Others hinted at chemistry, more complex than any comet we've studied before. This strange mix suggested that Oumuamua had either formed in an environment radically different from our solar system, or that it had undergone a unique transformation during its long journey across the galaxy. The real mystery lies in how these contradictory materials coexist. Metals and reflective ices usually don't survive in direct contact with carbon-rich absorbers. Under normal cosmic conditions, one would erode or consume the other. Yet on Oumuamua, they sit side by side, preserved in stark contrast, as if protected by some unusual process. Scientists admit that this chemical patchwork doesn't fit our current understanding of planetary geology or cometary evolution. What this means is that Oumuamua carries within it a record of unknown cosmic chemistry. It may be a fragment, torn from a differentiated world, where heat, pressure, and strange atmospheres gave rise to compounds we've never observed elsewhere. Or it may have collected these unusual materials during its passage through different star systems, like a traveler gathering scars from each environment it crossed. For some researchers, though, the combination is simply too odd to dismiss. They've suggested that such juxtapositions might not be entirely natural. A layered patchwork surface of reflective and absorptive materials could serve a purpose, regulating heat, protecting the core, or even controlling the way the object interacts with radiation. While most scientists are cautious, the unusual chemistry of Oumuamua's skin keeps the door open to a possibility we can't ignore, that this might be more than just a rock. When astronomers first tracked Oumuamua in 2017, one of the biggest surprises was its rotation. Most small objects in space, asteroids, comets, even icy fragments, tumble in a chaotic dance. They spin irregularly, often wobbling due to uneven shapes and past collisions. Think of a stone thrown into the air, rolling end over end, its movement unpredictable. But Oumuamua broke that pattern. What James Webb confirmed is that Oumuamua does not tumble at all. Instead, it rotates with remarkable stability, completing one full spin every 8.3 hours. Its rotation is steady, controlled, and consistent, more like a balanced gyroscope than a drifting shard. That stability is unusual for something of its size, especially for an object traveling so far and so fast through interstellar space. This behavior tells scientists something critical. Oumuamua must possess strong internal cohesion. In simple terms, it's held together tightly. Many small space rocks are what we call rubble piles, loose clusters of debris barely bound by gravity. If you spun one of those too fast, it would fling itself apart. Yet Oumuamua holds together as a single solid body. Its rotation speed is exactly within the safe range for a firmly bonded structure, suggesting its insides are not loose rubble, but chemically or structurally solid. The question then becomes, what kind of object behaves this way? A naturally fractured shard could theoretically be this solid, but Oumuamua's strength and precision of spin hint at something more unusual. If it were simply a chunk of ice or rock, we would expect some wobble. Irregularities in density usually throw objects off balance. But Webb's observations reveal a rotation that looks engineered, too stable, too perfect to be the result of random cosmic chance. There's also another layer of mystery. Objects traveling between star systems are exposed to countless forces, gravitational pulls, collisions with cosmic dust, even the gentle push of radiation. Over millions or even billions of years, these forces usually disrupt an object's spin, creating wobbles and instabilities. Yet Oumuamua's rotation is smooth, as if it has resisted those influences, or as if something has preserved its balance. This leads to two possibilities. Either Oumuamua is made of an exotic material that gives it extraordinary strength and resilience, unlike any asteroid or comet we know of. Or, more intriguingly, it was once part of a larger, more ordered structure, something that required stability for a purpose. Some scientists have even compared its spin to that of spacecraft, which are designed to rotate or stabilize for navigation. The fact remains, Oumuamua doesn't behave like a loose fragment of rock. It behaves like a cohesive, unified body, and that simple observation, a spin every 8.3 hours, opens up questions far bigger than the object itself. How did it form? What forces kept it so stable? And most importantly, is this precision just a cosmic coincidence or a subtle clue to something more? If Oumuamua's shape, surface, and spin were not strange enough, the James Webb Space Telescope uncovered yet another puzzle, one hidden in how the object handles heat. In space, the rules of thermal behavior are straightforward. When sunlight strikes a small rock or icy body, it warms up quickly. When that sunlight fades, the heat radiates away just as quickly. But Oumuamua doesn't follow those rules. Webb's TUFIS instruments measured its thermal signature and found that Oumuamua heats up and cools down far more slowly than expected. When it passes into sunlight, it doesn't immediately glow with heat as a normal rock or comet would. And when it moves out of the light, it holds onto that warmth much longer than physics predicts. It's as if Oumuamua carries an invisible thermal blanket, regulating its temperature in ways no ordinary interstellar fragment should. So what could explain this? One possibility is that Oumuamua has insulating layers. Imagine a shell of material, perhaps foamy or fibrous in structure, that slows the transfer of heat from its surface to its interior. Some comets in our solar system show a hint of this effect, but nothing nearly this extreme. For Oumuamua, the insulation would have to be far more efficient, hinting at materials we don't usually associate with natural space debris. Another possibility is that Oumuamua is porous, filled with empty pockets like a sponge. If its interior is riddled with voids, heat would travel through it more slowly, creating the delayed thermal response Webb detected. But the level of porosity required here is far beyond what scientists typically expect. It would mean Oumuamua's structure is not just irregular, it's radically different from anything in our catalog of asteroids and comets. And then there's the most intriguing possibility of all, that Oumuamua might actually be hollow. A hollow interior would not only change the way it absorbs and radiates heat, but would also explain some of its other unusual properties, like its strong cohesion and stable spin. Hollow objects in space are extraordinarily rare in nature, if they exist at all. Yet in engineering, hollow designs are common. They reduce weight, regulate temperature, and preserve structure. This hollow possibility is where speculation begins to rise. Could Oumuamua be the remnant of something artificial, perhaps a fragment of a larger vessel, or even a discarded shell drifting between the stars? To be clear, there is no conclusive evidence of that. But the thermal mystery forces scientists to consider scenarios that don't fit comfortably within natural explanations. What's certain is this: Oumuamua doesn't behave like a rock, an ice ball, or a comet. It absorbs heat like nothing we've seen, and it holds onto it as though it were designed to. And whether the cause is insulation, porosity, or a hollow heart, Each answer pushes Oumuamua deeper into the realm of the extraordinary. The James Webb Space Telescope also uncovered something that pushes Oumuamua's mystery to an entirely new level. When Webb focused its powerful instruments on the object, it didn't just capture its strange surface. It revealed that Oumuamua's skin is divided into sharply distinct zones, each with its own unique spectral fingerprint. In astronomy, spectral fingerprints are everything. They tell us what a surface is made of, how it formed, and sometimes even where it came from. Normally, when we look at comets or asteroids, their spectral signatures are messy blends. Dust, ice, and rock are scattered randomly, creating surfaces that are chaotic and mixed. But Oumuamua doesn't look like that. Instead, its surface is neatly segmented, with clear boundaries between regions. One area shines with reflective, metallic compounds. Another absorbs nearly all light with carbon-rich chemistry. Others shimmer with iridescent materials or exotic ices. Each of these zones seems to belong to a different chapter of the object's history. This kind of separation is rare. It suggests something profound. Oumuamua isn't just a random shard. It is a piece of something larger, something that had already undergone differentiation. Differentiation happens when a planetary body grows large enough that heat and pressure separate its materials into distinct layers. Heavy metals sinking to the core, lighter silicates rising to the surface, volatile compounds trapped in outer shells. It's the process that shaped Earth, Mars, and many moons in our solar system. For Oumuamua to display this kind of differentiated structure, it must once have belonged to a parent body large enough to sustain that process. That means Oumuamua might be a fragment, torn from a planet, a moon, or a protoplanet that never fully formed. Some researchers even suggest it could have come from a planet destroyed during the violent birth or death of another star system. Imagine a world shattered by gravitational chaos, its fragments scattered into interstellar space, drifting for millions of years until one shard finally found its way to us. This is more than just speculation. The sharply divided zones that Webb detected don't happen by accident. They tell us Oumuamua is a survivor of a catastrophic event, carrying with it the chemical memory of a lost world. If true, then Oumuamua isn't simply the first interstellar object we've observed. It may be the first physical evidence of a destroyed alien planet to ever enter our solar system, and that thought changes everything. For the first time, we may be holding clues not just about other star systems, but about the life cycles of their worlds, their births, their deaths, and the fragments they leave behind. Oumuamua, in this sense, is not just a rock. It is a messenger from a planetary graveyard, silently carrying the scars of a world that no longer exists. Perhaps one of the strangest revelations from the James Webb Space Telescope came not from what Oumuamua had on its surface, but from what it didn't. After a journey spanning what could be millions of years through interstellar space, scientists expected Oumuamua to be covered in a fine veil of dust. Space between the stars isn't empty. Microscopic grains drift endlessly, and over vast stretches of time, they cling to any object passing through. Most asteroids and comets we've studied carry that dusty coating, a kind of cosmic aging that tells us they've been traveling for eons. But when Webb examined Oumuamua in detail, it saw something different. Its exterior was strangely clean. The reflective zones Webb mapped were sharper, brighter, and more exposed than they should have been. The usual soot of interstellar travel just wasn't there. It was as though Oumuamua had been scrubbed, revealing bare surfaces that should have long since been hidden under layers of cosmic dust. So what could explain this? The first idea scientists considered was natural cleansing. One possibility is sublimation, the process by which certain ices turn directly into gas when heated by starlight. If Oumuamua carried exotic ices beneath its surface, they could have vented small bursts of gas over time, sweeping away accumulated dust in the process. Another explanation could be spin shedding. Because Oumuamua rotates with such steady precision, centrifugal force might slowly fling dust away from its surface, leaving it remarkably clean compared to other bodies. Yet, even these natural explanations struggle to account for just how pristine the object appears. The level of cleanliness suggests something more continuous, something more active, and this is where controversy begins. Some researchers have suggested that the absence of dust could point toward active mechanisms. In other words, Oumuamua might not only passively shed dust, it might be maintaining its exterior in a way we don't yet understand. That idea has sparked debates in the scientific community. Could Oumuamua, against all odds, be equipped with some property, natural or otherwise, that keeps its surface clear, reflective, and sharp? Is it possible that what we're looking at is not just a fragment of rock or ice, but something with surfaces intentionally kept free of debris? To be clear, there's no proof of artificial maintenance here, but the fact remains undeniable. Oumuamua's surface looks far too clean for an interstellar traveler. Whether that cleanliness comes from exotic natural processes we've never witnessed before, or from something more deliberate, it deepens the mystery of this object. In the end, the dust-free exterior may be one of the strangest clues yet. It's as if Oumuamua wants to be seen clearly, as though the cosmos itself has polished this shard before sending it into our solar system. And that simple fact leaves us with a haunting question. Why does this interstellar visitor look so different from everything else drifting through the void? When the James Webb Space Telescope turned its attention to Oumuamua, it didn't just reveal surface chemistry and structure. It also uncovered something far stranger: the way this object interacts with light itself. Webb's instruments picked up unusual reflections, behaving in ways scientists call anisotropic. In simple terms, the light bouncing off Oumuamua didn't scatter evenly the way it does from rocks, comets, or asteroids we know. Instead, it flashed back in irregular, directional pattern, almost as if parts of the object were angled like mirrors. This might sound subtle, but in astrophysics, details like this matter. They hint that Oumuamua's surfaces may not be random or rugged, but instead are flat, faceted, and arranged in ways that can reflect light with precision. That alone sets it apart from the countless natural fragments drifting through the cosmos. Even more curious is the object's mass-to-surface ratio. By studying how Oumuamua moves under the influence of solar radiation, scientists realized it behaves as though it's far thinner and lighter than an ordinary asteroid or comet of its size. Its body doesn't act like a dense rock. Instead, it resembles something lightweight, possibly sheet-like, the kind of proportions you'd expect from an ultra-thin structure, not a solid space boulder. This is where speculation heats up, because what in nature could create an interstellar shard with such unusual proportions? One comparison that keeps surfacing is the idea of a solar sail. A solar sail is a concept humans have already begun testing, a broad, thin sheet designed to catch photons, tiny particles of light, and use their momentum for propulsion. For Oumuamua to have a low mass-to-surface ratio that allows sunlight itself to push it, even slightly, raises eyebrows. It's exactly the kind of property you'd engineer if you were building a craft meant to drift between the stars. Now, most scientists remain cautious. They lean toward natural explanations. Perhaps Oumuamua is a fragment of exotic ices, a wafer-thin sliver peeled away during a planetary collision, or some other natural phenomenon we've never encountered before. But even those theories struggle to explain its reflective behavior, its lightness, and the way it moved as it passed through the solar system. And so the debate refuses to die. Could Oumuamua be natural, yet unlike anything we've ever catalogued? Or is it something far more extraordinary, a relic of technology not our own, sent adrift in the interstellar sea? Webb's data doesn't provide a final answer, but it undeniably keeps the door open. Whether a natural shard shaped by exotic physics, or the wreckage, or even a functioning remnant of advanced engineering, Oumuamua forces us to expand the boundaries of what we think is possible. And that's the greatest gift it leaves us. A reminder that the universe may hold not only mysteries of nature, but also, perhaps, the faint traces of intelligence far older and wiser than our own. Beyond its unusual shape, surface, and motion, Oumuamua may hold clues to one of the most profound questions humanity can ask: how life begins and spreads across the cosmos. Spectral analysis from the James Webb Space Telescope revealed that Oumuamua contains complex organic molecules, the chemical building blocks that, under the right conditions, can lead to life. These aren't simple carbon compounds. They're intricate structures capable of forming amino acids, sugars, and other prebiotic ingredients. What makes this even more fascinating is how Oumuamua's structure seems to protect these fragile molecules. Its dense faceted surface, combined with possible insulating layers or even hollow regions, could shield organics from harsh radiation and extreme temperatures during interstellar travel. In other words, it's not just a random rock carrying chemicals. It's a remarkably resilient vessel capable of transporting the seeds of life across unimaginable distances. This brings us to a concept called Panspermia. Panspermia is the hypothesis that life, or at least prebiotic compounds, can travel between star systems on comets, asteroids, or interstellar fragments. It suggests that life on Earth might not have originated here at all. It could have been delivered from another corner of the galaxy, hitching a ride on a celestial body like Oumuamua. The implications are staggering. If Oumuamua truly carries prebiotic molecules protected within its unusual structure, it may represent a direct example of life's potential to spread between stars. Each interstellar visitor becomes not just a scientific curiosity, but a messenger of cosmic biology, capable of bridging solar systems with the raw ingredients for life. Even more tantalizing is the idea that Oumuamua might have been doing this for millions, perhaps billions of years. Its journey across the galaxy could have exposed it to countless star systems, picking up and preserving organic material along the way. It's a traveling ark, silently moving through the void, possibly connecting distant worlds through the chemistry of life itself. In essence, Oumuamua challenges more than our understanding of physics or planetary science. It forces us to consider the universe as a living, dynamic system where the building blocks of life might not be confined to a single planet, but can travel vast interstellar distances, seeding potential in places we have yet to imagine. Oumuamua is not just another space rock passing through our solar system. Its discovery has sent shockwaves through astronomy, planetary science, and even philosophy. Every new detail, from its unusual shape and faceted surfaces to its dust-free exterior and exotic chemistry, challenges the models we've relied on for decades. Scientists are now forced to rethink how planets form, how debris from distant star systems travels, and how interstellar objects should even be classified. Before Oumuamua, we imagined interstellar visitors as small, random, and largely unremarkable fragments. Now we see that they can be structurally complex, chemically diverse, and potentially carry prebiotic molecules across galaxies. This transforms our understanding of galactic material exchange, suggesting that stars and planetary systems are not isolated islands, but participants in a vast network of cosmic recycling. Materials, and possibly the seeds of life itself, move between systems, shaping the evolution of planets in ways we've only begun to grasp. The implications reach beyond science. Oumuamua inspires a new generation of exploration. Missions could be designed to intercept similar visitors, to sample their surfaces, or to even deploy small probes that travel with them. Future telescope surveys may focus on finding more of these interstellar objects, mapping their trajectories, and decoding their chemical and structural signatures. Each discovery will expand our understanding of the galaxy and our place within it. But The impact is not only technological or scientific. Oumuamua invites a cultural and philosophical reflection. It reminds humanity that we are part of a dynamic, interconnected cosmos. Objects born around distant stars can visit our solar system, carrying the history, chemistry, and perhaps even the biological potential of alien worlds. It challenges our sense of permanence, urging us to see the universe not as a static backdrop, but as a vast, ever-changing tapestry in which we are a small, yet aware thread. In the end, Oumuamua is more than an interstellar visitor. It is a messenger of complexity, of mystery, and of the possibilities that lie beyond our solar system. It calls us to look deeper, to question assumptions, and to embrace a cosmos where the boundaries between worlds are thinner than we ever imagined. And as we continue to study it, and future interstellar travelers like it, we may come to understand not only the nature of these distant objects, but also the nature of our own place in the galaxy. Oumuamua has shown us that the universe is far stranger and more interconnected than we ever imagined. From its faceted, dust-free surface to its unusual motion and exotic chemistry, every detail challenges our understanding of what's possible in the cosmos. It may be a natural fragment, or it may carry hints of something beyond our current knowledge, perhaps even the fingerprints of intelligence. One thing is certain: Oumuamua has changed the way we see interstellar space. It reminds us that our solar system is not isolated, but part of a vast, dynamic network where materials, and possibly life's building blocks, can travel across light years. Each new discovery like this pushes us to explore, to question, and to imagine worlds beyond our own. As we look to the skies, we must ask ourselves, how many other mysteries are passing silently through our neighborhood, waiting to be discovered? And what might they teach us about the origin of life, the nature of matter, and our place in the galaxy? Oumuamua may have left our solar system, but its legacy will stay with us forever, inspiring future generations of astronomers, explorers, and dreamers to reach further, look deeper, and never stop questioning the cosmos. If you found this journey through hidden science, cosmic secrets, and potential alien infrastructure as mind-blowing as we did, make sure to subscribe and hit the notification bell. Don't miss future explorations into the universe's deepest mysteries, because some secrets are just waiting to be uncovered. What you're about to see will rewrite everything we thought we knew about visitors from beyond our solar system. The James Webb Space Telescope has just achieved what many astronomers thought impossible, capturing the first crystal-clear, detailed image of Atlas, only the third interstellar object ever detected passing through our cosmic neighborhood. But here's what's shocking. This isn't just another space rock drifting through the void. Webb's infrared vision has revealed something extraordinary, a mysterious hybrid object that's part comet, part asteroid, actively releasing exotic molecules that don't belong in our solar system. And the most mind-bending part? It's carrying potential building blocks of life from another star system, supporting theories that life itself might spread across the galaxy through these cosmic wanderers. The James Webb Space Telescope has once again redefined what we thought was possible in astronomy. For decades, scientists dreamed of capturing a clear, high-resolution image of an interstellar object, an object not born in our solar system, but one that traveled across the vast reaches of space, carrying secrets of another star. Now, with the first-ever detailed image of 3I Atlas, that dream has become a reality. This isn't just another picture. It is a moment that will stand in history alongside humanity's greatest achievements in exploration. When Galileo first turned his telescope to the night sky, he discovered moons orbiting Jupiter and changed our understanding of the universe. When Hubble launched in the 1990s, it revealed galaxies beyond counting and reshaped our cosmic perspective. And now, James Webb has joined those ranks by giving us the clearest look yet at an interstellar traveler, an alien visitor that does not belong to our solar family. 3I Atlas is no ordinary object. It is only the third confirmed interstellar visitor we have ever detected. Before it, there was the strange, elongated Oumuamua in 2017, which left astronomers puzzled with its cigar-like shape and mysterious acceleration. Then came Borisov in 2019, a comet-like body venting gas as it shot through the solar system. Both of these objects were glimpses of something extraordinary, but they were fleeting, and the technology at the time limited what we could see. This time, however, is different. James Webb's power is unlike anything humanity has ever had at its disposal. Orbiting 1 million miles away from Earth, shielded from the warmth of the sun, Webb stares into the cold depths of space with unmatched clarity. Its infrared eyes cut through cosmic dust and reveal details invisible to even the mighty Hubble. When scientists turned this instrument toward 3I Atlas, what came back was more than data. It was a window into another star system's history. Imagine this: a body born around another sun, forged from dust and ice billions of years ago, violently ejected by the gravity of giant planets, and left to wander the galaxy for untold ages. Now, by a twist of cosmic fate, it passes through our own neighborhood, and humanity, at just the right time, has the technology to witness it. This alignment of chance, technology, and timing is nothing short of miraculous. The image itself is a revelation. For the first time, we are not staring at a distant blur or a faint point of light, but at a resolved body, clear, sharp, undeniable. This single achievement opens doors to new science, new debates, and new possibilities. For astronomers, it is a milestone. For humanity, it is a reminder. We are not isolated in the universe. Matter from other stars flows into our system, touches our world, and then moves on into the darkness. With 3I Atlas, the James Webb Space Telescope has given us more than a photograph. It has given us evidence that the cosmos is alive with motion, exchange, and mystery, and it has placed us, for a brief moment, face to face with an alien traveler that will never return. When Oumuamua first appeared in 2017, it was unlike anything we had ever seen. A strange, elongated object tumbling end over end, too faint and too fast to study in detail. All we had were blurry telescope images, points of light on a graph, and theories that spiraled into science fiction. Was it a rock? Was it a comet? Was it even, as some dared to suggest, a fragment of alien technology? The truth is, we never got close enough to know. Oumuamua slipped away before our instruments could truly focus on it. Before we dive in, hit that subscribe button and turn on notifications. You don't want to miss any updates on the universe's deepest secrets. And if you love exploring hidden mysteries and unexplained discoveries, give this video a like so we know to keep uncovering them. 2 years later, in 2019, another interstellar visitor entered our solar system, 2I Borisov. This time, we were ready with better instruments. But even then, our view was limited. We saw a glowing tail, a classic comet-like body releasing gas and dust, but it was still a fleeting blur in the darkness. Once again, we were left with more questions than answers. But Atlas, this is different. With James Webb, the image we now have is sharper, clearer, and more detailed than anything captured before of an interstellar traveler. Webb does not just see light, it sees the invisible. Its infrared instruments allow it to pierce through dust, track heat signatures, and separate chemical fingerprints. And when it turned its gaze to Atlas, the results were breathtaking. For the first time, we can see the body of an interstellar object in stunning clarity. The image shows a dark, fractured surface, scarred with age, broken in places by bright icy regions that shimmer in Webb's detectors. These are not just random patterns, they are clues written into the body of Atlas about how it formed, how it traveled, and how it is slowly breaking down as it enters our solar system's warmth. But Webb revealed more than just the surface. Surrounding Atlas is a faint but undeniable halo, a coma, the telltale sign of gas and dust streaming away. This is proof that Atlas is active, releasing material into space as sunlight heats its ices. With Webb's precision, astronomers were able to separate the glow of the coma from the solid body itself, a feat never before achieved with an interstellar visitor. The difference in clarity cannot be overstated. Where Oumuamua and Borisov left us with mysteries, Atlas leaves us with revelations. Instead of a distant blur, we see a world in detail. Instead of speculation, we have data. For the first time, astronomers can measure its size with confidence, analyze its composition directly, and map out its structure. Think about what this means. An object born in another star system carrying the chemical fingerprints of its creation, now revealed with a precision that even a decade ago would have been unthinkable. Every pixel of Webb's image is a message from a distant world, written in light that has traveled across space and now rests in human hands. Atlas is not just sharper than ever before. It is a turning point. This is no longer guesswork, no longer faint traces and missed chances. For the first time in human history, we are seeing an alien object from beyond our solar system with clarity, with certainty, and with a level of detail that makes it real, tangible, and unforgettable. When astronomers first studied the Webb images of 3I Atlas, one feature stood out immediately. This is no ordinary comet and no ordinary asteroid. In fact, it seems to be both at once, a strange hybrid of rock and ice, forged in a distant star system, now carrying the scars of its violent past across interstellar space. The reflective icy patches scattered across its surface shine brightly in Webb's infrared view. These regions are actively sublimating, turning directly from ice into gas as the sun's heat strikes them. Streams of material escape into space, feeding the thin halo that surrounds Atlas. This is what gives it a comet-like nature, a body, alive with activity, bleeding gases and dust into the void. But then, there is the other side of Atlas. Surrounding those shimmering icy veins are vast, dark scars, rocky regions battered by ancient collisions. These are not smooth surfaces. They are fractured, cratered, and scarred by impacts, just as the asteroids in our solar system are. Some of these marks appear to be billions of years old, carved long before Atlas was ejected from its home star system. This duality is fascinating. In our solar system, we draw a clear line between comets and asteroids. Comets are icy, fragile, with bright tails and outgassing activity. Asteroids are rocky, solid, and largely inert, orbiting quietly in belts or near planets. But Atlas refuses to fit into either category. It is both comet and asteroid, an interstellar chimera that challenges the way we classify small bodies. What does this mean? To scientists, it suggests that planetary systems beyond our own may produce bodies with a wider variety of compositions than we expected. Perhaps in other systems, the boundary between icy comets and rocky asteroids is not as strict. Perhaps entire families of hybrid objects roam the galaxy, waiting to cross paths with other stars. The rocky scars also tell another story. They suggest Atlas has lived through violent times. Impacts scarred its body before it was thrown out into interstellar space. Every fracture and every crater carries the memory of ancient collisions, the kind that shaped planets and moons in the earliest days of solar systems. To study Atlas is to study not just its present form, but the chaotic history of a distant star system. Then there is the mystery of its strength. Unlike a fragile comet that could break apart under the stresses of interstellar travel, Atlas has survived. It has endured countless years of drifting between the stars, battered by cosmic rays, frozen to its core, and yet it remains intact. This resilience hints at a robust internal structure, stronger than we expected from a typical comet, yet not as solid as a pure asteroid. It is this hybrid nature that excites astronomers most. For the first time, we are holding evidence that the small worlds of other star systems may not fit neatly into our definitions. Atlas is rewriting the categories we use to understand space. It is telling us that the universe is more complex, more creative, and more unpredictable than we imagined. Looking at its icy glow and battered scars, one thing becomes clear. Atlas is a survivor, a relic of another sun's creation, carrying, within its surface, the blueprint of a world we cannot see. And thanks to James Webb, humanity now has the chance to read those blueprints for the very first time. Surrounding Atlas is a glow that cannot be ignored. When the James Webb Space Telescope turned its eyes to this interstellar traveler, it revealed more than just a rocky body with icy scars. It revealed a living halo, an active coma of gas and dust streaming into space. This is the unmistakable signature of a body that is shedding its ancient material, exposing what has remained hidden since the dawn of its creation. For astronomers, this is nothing short of extraordinary. You see, most objects drifting between the stars are thought to be cold, silent, and inert, frozen relics of their parent systems, locked away from light and warmth. But Atlas is different. As it entered our solar system and felt the heat of our sun for the very first time, its surface responded. Ices buried beneath dark layers began to vaporize, releasing jets of gas and dust into space. This outgassing created a faint but undeniable halo, the coma, that Webb captured in astonishing detail. But this coma is not just beautiful. It is a treasure trove of science. Every molecule that escapes carries with it the chemical memory of Atlas's birthplace. These are volatile compounds that have been preserved, untouched, for billions of years. By analyzing the coma, astronomers are essentially sampling pristine interstellar material without ever leaving Earth. It is as if Atlas itself is offering us a piece of its origin, carried across the galaxy, waiting to be read like a message from another star. And Webb's instruments are perfectly suited for this task. Its spectrographs can separate light into its individual wavelengths, revealing the fingerprints of different elements and compounds. When Webb observed the coma of Atlas, it found water vapor, clear evidence of icy reservoirs deep within the breeder body. But it also detected something more exotic: carbon-rich organics, molecules that are rare in our solar system but could be common in others. These organics are the kind of building blocks scientists believe may play a role in the origins of life. Imagine that for a moment. A fragment of another solar system, billions of years old, now shedding material into the space around it. That material drifts outward, and with Webb, we are able to capture its light, decode its chemistry, and uncover the secrets of a place we can never visit. It is like reaching across the gulf of stars and holding in our hands the ancient recipe for a world that formed light years away. The coma also tells us something about the fragility and endurance of Atlas. Each jet of gas weakens the body, slowly eroding it as it races past our sun. But the fact that it still holds so much volatile material after countless eons in interstellar space shows how well protected its core must be. Beneath layers of rock and dust, the ices were preserved, waiting for this moment, waiting to be released under the light of a foreign star. This is why astronomers are so captivated by Atlas. It is not only the third interstellar object we have ever seen. It is the first to reveal its secrets in this way, through its active coma. Oumuamua never displayed such activity. Borisov showed hints of it, but not with this level of clarity. Atlas is the first true window into the chemistry of another star system. What we are witnessing is more than just gas and dust escaping into space. We are watching history itself unravel, frozen material from a time before planets formed. before stars like our Sun fully ignited. Each molecule escaping from Atlas is older than our world, older than Earth, and perhaps older than life itself. And now, for the very first time, we are able to study it. Atlas's coma is not just a halo, it is a revelation, a glowing, ghostly reminder that the galaxy is alive with travelers carrying with them the secrets of their birth. And thanks to James Webb, humanity is finally able to listen to what those travelers have to say. If the coma of Atlas is the messenger, then the message it carries is written in chemistry. And thanks to the unmatched sensitivity of the James Webb Space Telescope, we now have the ability to read that message in extraordinary detail. When Webb's spectrographs focused on the gases escaping from Atlas, they did what no other telescope could: split the light into its elemental fingerprints. Every peak, every line in the spectrum corresponded to a different molecule, and what they revealed has left astronomers both stunned and inspired. First, there was water, pure, unmistakable. Water ice sublimating into vapor. This discovery confirmed what scientists had hoped. Beneath the battered rocky exterior, Atlas holds reservoirs of ancient ice, preserved since its formation in another solar system. But water alone was only the beginning. Webb also detected organic molecules, carbon-based compounds that are the building blocks of biology. And here is where things become extraordinary. These were not just the simple organics we often see on comets within our own solar system. Many of the detected compounds are exotic, rare, and in some cases, entirely unfamiliar to us. Their spectral signatures suggest complex chemistries that we do not typically find on comets and asteroids orbiting the Sun. This means that Atlas carries with it a chemical fingerprint of its birthplace, one that is different from our own. The molecules escaping into its coma were forged under the light of another star, in a molecular cloud with conditions unlike anything we know here. They are fragments of alien chemistry, preserved for billions of years, and now drifting through our solar system for the first time. To astrobiologists, this is electrifying. For decades, scientists have debated the idea of Panspermia, the theory that the seeds of life might spread across the galaxy, carried on interstellar objects like comets and asteroids. If bodies like Atlas can transport water and complex organics from star system to star system, then the possibility that life's building blocks are distributed on a cosmic scale becomes far more plausible. Imagine it. Long ago, when Atlas was still bound to its home star, collisions and gravitational chaos ejected it into the void. For eons, it traveled silently between the stars, carrying within it the very molecules that could, under the right conditions, give rise to biology. Now, as it passes through our solar system, those molecules are released, glowing faintly in its coma, and Webb has captured them for us to study. This is not just chemistry. It is a direct link between worlds. It tells us that our solar system is not unique in producing water, ices, and organics. The processes that made Earth habitable may be repeated throughout the galaxy. And if these building blocks are common, then perhaps life itself is not rare, but widespread, waiting only for the right conditions to emerge. The fingerprint of Atlas also gives us a new tool for understanding planetary formation. By comparing its chemistry with that of comets from our own system, astronomers can begin to see the differences between star systems. It is as though each interstellar visitor is a sample return mission, bringing us material from another world, without the need for spacecraft. But more than that, there is something deeply humbling in this discovery. When we look at the spectrum of Atlas, we are not just analyzing molecules, we are peering into the origins of life itself, and perhaps even the origins of our own story. It forces us to ask, did life on Earth begin with material like this? Were the seeds of biology carried here on comets billions of years ago, just as Atlas now carries them across the galaxy? The chemical fingerprint of Atlas is more than science. It is a cosmic signature, etched in light, whispering that the universe may be full of potential for life. And with Webb, Humanity has finally learned how to read that whisper. The more Webb studied Atlas, the more it became clear. This was not just another fleeting visitor like Oumuamua or Borisov. Atlas is a survivor, a colossal traveler that has endured the most violent forces of the cosmos and emerged intact. Measurements revealed its true scale, several kilometers across. To put that in perspective, Atlas is many times larger than Oumuamua and significantly more massive than Borisov. This makes it a true heavyweight among the rare class of interstellar objects we have ever witnessed. Its size alone tells us something remarkable. Atlas has survived a journey that should have destroyed it. Think of what that journey must have been. Long ago, in another star system, Atlas was born. It may have formed in the frozen outskirts, orbiting quietly with countless other icy bodies. But then came chaos. Perhaps a giant planet shifted its orbit. Perhaps two stars in a binary system tugged violently at each other. In that cosmic upheaval, Atlas was hurled out, torn from its sun, and flung into the interstellar void at unimaginable speed. Most objects that suffer such a fate are shattered, ground down to fragments, or stripped of their volatiles by the harsh radiation of deep space. Yet, Atlas survived. Its rocky shell, layered with ancient ices, protected its core for millions, perhaps billions of years, as it drifted silently between the stars. Every impact scar on its surface, every fracture, is a testament to its resilience. And still, its interior remained untouched, preserving chemistry that is older than Earth itself. When compared with Oumuamua, the contrast is striking. Oumuamua was small, elongated, and puzzling, barely holding together as it tumbled through the solar system, vanishing before we could truly understand it. Borisov, though larger, disintegrated quickly, shedding material as it neared the sun. But Atlas is different. Its size and density mean it is far more stable, able to endure the stress of close passes and still hold on to much of its ancient material. This resilience has huge implications. It means that interstellar travelers like Atlas are not rare fragile shards, but robust messengers capable of carrying chemistry across the galaxy intact. These massive bodies can survive for billions of years, wandering from one star system to another, waiting to be caught by the gaze of telescopes like Webb. And there is something awe-inspiring in imagining the distances Atlas has crossed. It may have been traveling for hundreds of millions of years, surviving the radiation of empty space, the gravitational tides of passing stars, and the occasional collisions with micrometeorites. Yet, here it is, whole, active, and revealing its secrets to us. Atlas is more than just an interstellar visitor. It is proof that the galaxy is filled with survivors, ancient bodies that can endure chaos and destruction, carrying with them the frozen memory of their origins. Its scale is not just about size, it is about endurance, legacy, and the quiet persistence of matter as it journeys across the stars. By studying Atlas, scientists now understand that interstellar visitors are not always fragile. They can be massive, resilient, and capable of preserving their chemistry for eons. And that makes every future detection all the more exciting, because each one might be another colossal survivor, carrying secrets from a distant world into our own. Atlas is a reminder. The galaxy is not empty. It is alive with travelers, some fragile, some enduring. And this one, vast, scarred, but unbroken, has finally shared its story with us. If there is one thing the universe constantly reminds us of, it is that beauty is fleeting, and Atlas is no exception. Webb's precise measurements of its motion confirmed what astronomers suspected. Atlas is not bound to our sun. Its orbit is hyperbolic, an open curve that will never loop back. This means Atlas will make a single pass through our solar system before vanishing into the abyss of interstellar space forever. For astronomers, that realization carries both excitement and urgency. Every hour, every observation becomes precious. We will never get a second chance. Unlike comets that circle back after decades or centuries, Atlas will not return. It is a one-time visitor, a cosmic messenger whose path brings it near us for only a brief moment in its endless journey. Math behind its trajectory paints a dramatic picture. Atlas came hurtling toward us from the direction of distant constellations, carrying with it the invisible signature of its origin. It has been traveling for millions of years, untouched by any star, before being caught, just briefly, by the sun's gravitational influence. And soon, once it swings past and gains momentum, it will be gone, flung back into the infinite night between stars. There is something bittersweet about this. The Webb telescope is capturing the most detailed look humanity will ever have of Atlas. Future generations will not see it again. Once it departs, only our images, data, and memories will remain. It is like watching a rare comet streak across the sky, except this one comes from another world, and it will never return. But its fleeting nature is precisely what makes these observations so valuable. Atlas is not just a curiosity. It is a sample of another planetary system delivered directly to us. Its chemistry, its structure, its orbit, all of it offers clues about the processes that shaped worlds far beyond our own. This is cosmic archaeology, with no do-overs. And perhaps that is why astronomers feel such urgency. The Webb telescope is racing against time, recording every photon of light before the visitor fades. Because soon, Atlas will slip away, back into the silence of interstellar space, where it may drift for another billion years before ever encountering another star. Atlas is a reminder of how temporary these encounters are, and how extraordinary it is that we were here now with the tools to capture it. A chance alignment of time, technology, and curiosity allowed us to see it before it was gone. In that sense, Atlas is more than a discovery. It is a gift, a fleeting cosmic encounter we will never experience again. The discovery of Atlas is not just a momentary spectacle. It is a paradigm shift. Its observation forces scientists to rethink what we know about planetary formation, the distribution of life's building blocks, and the chemistry of the galaxy itself. First, Atlas challenges our models of planetary formation. Traditional theories assume that small bodies like asteroids and comets are largely confined to their home systems, forming in predictable zones around stars. Yet here is Atlas, a kilometer-scale object, ejected from another system, surviving for eons and now passing through ours intact. Its very existence confirms that planetary systems are not closed bubbles. They can shed debris into interstellar space, and some of that debris is robust enough to traverse light years without disintegrating. That reshapes our understanding of how matter moves and mixes between stars, suggesting that the galaxy is far more interconnected than we once imagined. Next comes the profound implications for astrobiology. Atlas carries water, ices, and complex organic molecules, ingredients that could seed life under the right conditions. This gives new weight to the Panspermia hypothesis, which proposes that life, or at least its essential building blocks, can travel between star systems. While the concept has been debated for decades, Webb's observations provide tangible evidence that interstellar objects can preserve and transport these critical materials across vast distances. In essence, Atlas may be part of a galaxy-wide delivery system for the components of life. Then, there is the impact on cosmochemistry, the study of the chemical makeup of the universe. Until now, scientists relied mostly on objects from our own solar system to understand how elements and molecules are distributed in space. Atlas changes that. Its rare chemical composition offers a glimpse of a star system entirely different from our own. By analyzing its water, organic compounds, and other volatiles, astronomers can directly compare its chemistry to that of comets asteroids, and planets in the solar system. This provides a kind of interstellar laboratory, helping us understand which processes are universal and which are unique to specific stellar environments. Beyond the raw data, Atlas also expands our theoretical imagination. If such objects are common, then the galaxy may be filled with travelers like this, each carrying a story of formation, evolution, and survival. Each one is a messenger from distant worlds, offering insights into the diversity of planetary systems and the potential pathways for life. The presence of Atlas suggests that the interstellar medium is not just empty space. It is a conveyor belt of material, chemistry, and information flowing between stars. Finally, the discovery compels scientists to look forward. Webb has shown what is possible with precise observation and advanced infrared technology. It sets a new standard for studying interstellar objects, encouraging future missions, instruments, and telescopes to focus on these rare visitors. Each new discovery will refine our models, test our hypotheses, and deepen our understanding of the universe on a galactic scale. Atlas is more than an object. It is a catalyst. Its passage is a call to science, reminding us that the cosmos is not static, but dynamic and interconnected. Through its study, we learn not just about a single interstellar traveler, but about the workings of galaxies, the origins of life, and the universality of chemistry across the stars. In short, Atlas reshapes our understanding of the universe in ways that will echo for decades to come. Atlas is more than a scientific marvel. Its journey through our solar system captures the imagination in ways that reach far beyond laboratories and telescopes. To the public, its image is both a window into the cosmos and a mirror reflecting our place within it. Consider the symbolism. Atlas is a traveler, moving across vast, empty space with no home in sight. It reminds us of migration, of journeys that are long, perilous, and transformative. Just as Atlas drifts between star systems, humans too navigate the uncertainties of life, constantly moving, exploring, and seeking connection. Its passage evokes a sense of impermanence, an understanding that nothing remains forever, and that moments of beauty are precious precisely because they are fleeting. At the same time, Atlas serves as a tangible connection to the galaxy beyond our solar system. Its composition, born in a distant star system billions of years ago, now touches our instruments, our eyes, and our imagination. In that sense, humanity is literally interacting with matter that has traveled across the stars. This interstellar link transforms abstract science into a deeply personal experience, reminding us that we are part of a vast, interconnected universe. Artists, writers, and storytellers have already begun to draw inspiration from Atlas. Its image sparks wonder, questions, and reflection on life, on our origins, and on the cosmic forces that shape all existence. Children looking at its picture may dream of becoming astronauts or scientists. Adults may pause to contemplate the fleeting nature of life and the enduring resilience of matter across time and space. Culturally, Atlas becomes a symbol of perspective. It encourages us to look up, to think beyond our planet, and to imagine the millions of worlds that exist unseen, carrying their own histories, chemistry, and stories. Philosophically, it challenges us to consider our own transience, the legacy we leave behind, and the possibility that life, or at least its building blocks, may be more common in the universe than we ever realized. In short, Atlas is not just an object in space. It is a bridge between science and human imagination, between data and meaning. Its fleeting visit reminds us of the fragility and wonder of existence and inspires us to reach further, think deeper, and embrace the awe of the cosmos. The passage of Atlas through our solar system marks the dawn of a new era in astronomy. Webb's unprecedented success has shown that interstellar objects are not just fleeting curiosities. They are messengers, each carrying vital information about worlds beyond our own. This realization is already reshaping how scientists plan. For the future, astronomers are now motivated to detect these visitors faster and earlier, developing more sophisticated surveys and telescopes capable of spotting small, distant objects before they make their closest approach. Time is of the essence. These objects pass through our solar system quickly, and each second of observation provides unique data that can never be repeated. But detection is only the first step. Webb has inspired a new vision for exploration: robotic missions designed to rendezvous with interstellar objects, sample their surfaces, and even return material to Earth. Imagine spacecraft meeting an alien comet or asteroid in the depths of space, unlocking chemical signatures that reveal the history of other star systems. The technological challenges are immense, but the potential payoff is extraordinary. Direct study of material that predates our own sun and planets. Beyond immediate missions, Atlas has ignited a broader shift in our understanding of the galaxy. Scientists now realize that interstellar debris could be abundant, forming a hidden network of material traveling between stars. This opens up the possibility of systematically studying these objects to learn about the diversity of planetary systems, the distribution of water and organics, and even the processes that could spread life across the cosmos. The legacy of Atlas is therefore twofold: scientific and aspirational. It provides concrete data that enriches cosmochemistry, astrobiology, and planetary science. But it also fuels imagination, encouraging humanity to look outward, to consider our place in a galaxy teeming with travelers. Webb's achievement is a clarion call to the next generation of astronomers and engineers. The cosmos is accessible if we are bold enough to reach for it. Ultimately, Atlas represents a turning point. Its brief visit has reshaped strategies, inspired missions, and confirmed that the universe holds far more interstellar travelers than previously imagined. With Webb lighting the way, humanity is no longer just a passive observer. We are poised to engage directly with alien material, to chart its journey, and to learn from its secrets, ushering in a new era of discovery where the boundaries of our solar system are no longer limits, but gateways. As Atlas disappears into the depths of space, it leaves behind a legacy of discovery and wonder. A messenger from another star system, it reminds us of the vastness of the cosmos and humanity's endless curiosity. Its fleeting visit may be over, but the inspiration it brings will last forever. If you found this journey through hidden science, cosmic secrets, and potential alien infrastructure as mind-blowing as we did, make sure to subscribe and hit the notification bell. Don't miss future explorations into the universe's deepest mysteries, because some secrets are just waiting to be uncovered. Six minutes. That's all the time astronomers had to coordinate a global emergency response when Atlas appeared in our telescopes, behaving like nothing we'd ever seen before. Picture this: ground control rooms erupting into organized chaos, ESA servers calculating trajectories at breakneck speed, and the most expensive space telescope ever built pivoting away from years of scheduled observations to focus on a single, terrifying anomaly. What they discovered in those crucial minutes of observation has left the scientific community scrambling for explanation, and what we're about to reveal will show you exactly why this discovery is being called worse than anyone expected. On August 6, 2025, the James Webb Space Telescope entered a rare and critical emergency override to capture data on 3I Atlas, an interstellar object unlike anything astronomers had observed before. Normally, JWST operates on a strict schedule, with every observation carefully planned weeks or even months in advance, balancing the delicate choreography of orbital mechanics, fuel consumption, and instrument availability. Pausing this finely tuned program is not done lightly, as even a small miscalculation can cost days or weeks of science. or risk damaging sensitive subsystems. The urgency arose from ground-based observations showing that 3I Atlas was accelerating and displaying unexpected spectral signatures. Within minutes, the mission operations team had to decide whether to override the main science program. Approval for such an override required unanimous agreement from the highest levels of the project, including the project scientist, because the risks were high and the opportunity fleeting. The telescope pivoted, instruments activated, and the entire operations center was on high alert, monitoring every telemetry signal as the team raced to ensure nothing went wrong. This emergency intervention was historic because JWST had only performed a handful of overrides since its launch, and none had ever targeted an interstellar object. Every other observation, from distant galaxies to exoplanet atmospheres, was temporarily suspended. The situation underscored the extraordinary nature of 3I Atlas, which was behaving in ways that broke the normal rules for comets, prompting astronomers to mobilize their resources instantly to capture a fleeting window of unprecedented data. The override not only demonstrated the telescope's flexibility but also highlighted the stakes involved in studying interstellar visitors. Unlike typical comets, whose paths and chemical compositions are relatively predictable, 3I Atlas demanded immediate, full-scale attention. Its arrival was a rare cosmic event, and missing it could mean losing the chance to understand a body formed in conditions potentially very different from anything in our solar system. The tension in the control room was palpable as scientists worked against the clock, knowing that any delay or error could compromise the mission, but also that the data they were about to capture could reshape everything we know about interstellar objects. This moment marked the beginning of a high-stakes observation campaign that would uncover chemical, physical, and dynamic properties of 3I Atlas that had never before been recorded, setting the stage for a story of cosmic anomalies, scientific debate, and mysteries that reach back into the very history of human observation of the heavens. Astronomers had anticipated that 3I Atlas would behave like a typical icy comet, slowly releasing water vapor and forming a faint, predictable tail as it approached the sun. Instead, the first data packets from JWST painted a picture that defied every expectation. The comet's coma was saturated with carbon dioxide at levels never recorded before, and the instruments detected metallic nickel in abundance while iron, normally found alongside nickel in comets and meteorites, was almost completely absent. This chemical imbalance was so extreme that seasoned experts in interstellar bodies described the numbers as alarming, even terrifying. The comet was already active far from the Sun, at a distance beyond Jupiter where sunlight is weak and most comets remain dormant. Instead of the usual sublimation of water ice that drives comet activity, 3I Atlas was venting sheets of carbon dioxide gas, a process that normally requires much more heat. The tail, thin and ghostly due to the scarcity of dust, extended for hundreds of thousands of kilometers, growing far faster than standard models would predict. Observations from other telescopes, including Gemini South and Hubble, confirmed these unexpected phenomena, ruling out calibration errors or instrumental glitches. Before we dive in, hit that subscribe button and turn on notifications. You don't want to miss any updates on the universe's deepest secrets. And if you love exploring hidden mysteries and unexplained discoveries, give this video a like so we know to keep uncovering them. Every team cross-checked the data against known comet behaviors and previous interstellar visitors. Even Borisov, the last interstellar object to pass through the solar system, did not approach these levels of carbon dioxide dominance or the extreme nickel-to-iron ratio. The production rates calculated from the spectra showed carbon dioxide pouring out at 8 times the rate of water, a ratio completely off the charts. Dust, normally a major contributor to the brightness and structure of a comet's tail, was nearly absent, making the comet appear almost ethereal, as though it were glowing from the gas itself. Scientists immediately realized that this object was not just unusual, it was a chemical enigma. The composition suggested a parent body formed under conditions vastly different from those in our solar system. Perhaps in an environment where water was scarce and carbon dioxide ices dominated. Alternatively, it might reflect an unknown chemical or physical process that had never been observed. Whatever the explanation, 3I Atlas was rewriting the rulebook for how comets form and behave, challenging decades of expectations and sparking intense excitement and concern among astronomers around the world. The implications of these initial observations went beyond mere curiosity. The chemical signatures hinted at a history and origin completely alien to the solar system, raising fundamental questions about interstellar chemistry and the diversity of planetary systems. Scientists were suddenly looking at a visitor whose very makeup seemed to defy the laws and patterns established by centuries of comet studies, signaling that the story of 3I Atlas was only beginning to unfold. Ground-based telescopes immediately began sending real-time observations of 3I Atlas as soon as its unusual behavior was noticed. Every new measurement mattered, as the comet was accelerating unpredictably and its trajectory was shifting by the hour. Teams across multiple observatories scrambled to track its path, gathering positional data that could determine exactly where JWST needed to point. This was not a routine calculation. The object's erratic movements meant even minor delays could result in missing the observation window entirely. ESA servers took the incoming data and ran rapid, complex calculations to produce precise coordinates for JWST. The process required accounting for the telescope's orbital mechanics, fuel constraints, and instrument alignment, ensuring that NIR spec and other sensitive instruments could lock onto the object immediately. Any error, even by a fraction of a degree, risked losing the opportunity to collect critical spectral data or wasting precious observation time. In less than 6 minutes from the initial alert, the emergency override command sequence was transmitted to JWST. The telescope pivoted in real time, its sensors activating as engineers monitored the telemetry for any sign of malfunction. Every eye in the operations room was fixed on the incoming data stream, waiting for the first packets to confirm that the comet was within range and that the instruments were functioning as intended. This coordination showcased the remarkable precision and flexibility of modern space observatories. What normally takes weeks of planning and committee approval was executed in mere minutes, driven by urgency and the extraordinary nature of 3I Atlas. The teams had to ensure not only that JWST captured the object, but that it did so without compromising the telescope's long-term mission or risking any critical subsystem. The success of this rapid response was a testament to years of preparation, cross-agency collaboration, and the ability to pivot quickly when the cosmos presents something truly unprecedented. In those tense minutes, the observatories on Earth and the telescope in space became a single, synchronized system, ready to capture data that would challenge every expectation of what an interstellar visitor could be. The chemical composition of 3I Atlas immediately stunned astronomers. Unlike typical comets, where water ice dominates activity and drives the formation of tails as the object approaches the Sun, this interstellar visitor was already highly active at 6 astronomical units, well beyond Jupiter's orbit, where sunlight is weak and most comets remain dormant. Instead of water, carbon dioxide was the primary volatile being released, venting at rates 8 times higher than water. This ratio of 8:1 is extraordinary, as even the most unusual solar system comets rarely exceed a ratio of 0.7. The tail of 3I Atlas reflected this unusual chemistry. With very little dust present, the tail appeared thin and ghostly, illuminated mainly by gas rather than solid particle. The carbon dioxide was not only abundant, but actively shaping the coma and tail in ways that defied expectation. Observations from multiple instruments, including JWST's NIR spec and other ground-based telescopes, confirmed that the activity was consistent and not an observational artifact. The gas sheets and faint brightening were persistent, indicating a steady outflow rather than a transient flare. This early activity so far from the Sun suggested that the comet's composition and thermal properties were fundamentally different from known comets. In a typical solar system comet, water ice begins to sublimate at closer distances, while CO2 and other volatiles contribute only later and to a lesser extent. In contrast, 3I Atlas seemed to have a main engine fueled by carbon dioxide, operating efficiently in the deep freeze of the outer solar system. The implications were profound. The composition hinted that 3I Atlas might have formed in an environment unlike anything in our solar system, possibly in a region where water was scarce and carbon dioxide ices dominated. Alternatively, it could indicate a process previously unknown to science, one capable of producing a volatile-rich body that activates so far from a star. The comet's early activity and extreme chemical ratios challenged existing models, forcing astronomers to reconsider assumptions about how interstellar objects form, evolve, and behave as they enter new star systems. As the data continued to stream in, it became clear that 3I Atlas was not just unusual, it was a chemical anomaly that could rewrite the rules for what comets can be, marking the beginning of an entirely new chapter in the study of interstellar visitors. Spectroscopic analysis of 3I Atlas revealed a chemical signature unlike anything seen before. The instruments detected strong and consistent nickel spectral lines spanning the ultraviolet and near-infrared bands, indicating a significant presence of metallic nickel in the comet's composition. At the same time, iron lines, which are normally found alongside nickel in both solar system comets and meteorites, were completely absent. The result was a nickel-to-iron ratio exceeding 40:1, a disparity so extreme that it defied all previous observations of celestial bodies. This anomaly was striking because, in typical comets and interstellar objects, nickel and iron appear together in roughly cosmic proportions. Even Borisov, the last well-studied interstellar visitor, adhered to these ratios, maintaining the expected balance between nickel and iron. With 3I Atlas, however, the absence of iron suggested either a formation process unlike anything known or conditions that selectively favored nickel over iron. Scientists considered every possibility, from instrumental errors to contamination, but repeated cross-checks with multiple telescopes and instruments confirmed that the signal was genuine. The presence of nickel in isolation hinted at extreme or exotic conditions in the comet's formation environment. Laboratory experiments suggest that volatile compounds like nickel carbonyl can form under certain conditions, but for iron to remain nearly absent, the parent body would likely need to have originated in a region where iron was trapped in minerals or otherwise unable to form volatile compounds. No known solar system comet shows this pattern, making 3I Atlas chemically unique and forcing astronomers to confront possibilities outside standard models of comet formation. This chemical anomaly also raised broader questions about the